Everything okay? No. Everything is okay? Everything means same. Visibility plus voice plus laptop problem. Laptop problem is okay now. Okay, we'll start. See, 1 minute, I'll put a border line. So that later, I don't want to turn the camera. Sometimes what happens is turning camera becomes difficult. Just a minute. Yes. From here, no problem. Here up to furthermore. Yes, up to here, no problem. Okay, got it. Bottom is not a problem. Top fully visible. Bottom also full. Bottom, anyway, I don't have to worry. Now, yesterday's question. See, 1 minute. Why this pen? It's okay. Yesterday's question, check for shear pending. I won't waste time writing check for what shear. Already told you. So I will write here. Last part. Check for one-way shear. One-way shear. Just to understand, that is also called as wide beam shear, or you can tell our usual shear. Some will start wondering, what is usual shear? My students know it, that's all, keep quiet. Usual shear, or you get shear which will cause diagonal tension. This is all told for you. This is our usual shear, not punching. This everything is thoroughly explained. Okay, now it is actually not required, but there is a reason for it. I will tell you what is the reason. Why I am taking up now? There is a reason. Otherwise, I don't have to worry about it. See, first write one statement. Red color I will write. Tell fast. Critical section will be, as per IS code. IS code will be at what distance? Tell me. First of all, everything is over. Critical section will be at what distance? I will not ask you everything now because this is repetition. So I will ask minimum. Only thing is something important is there now. Critical section will be at D from face of the column. Face of column. See. Now there is a reason for this one now. See. First I will do one thing. I will put the plan, so that it is fully clear now. Further sketch I am not writing because there is a reason. Plan. This length is, I have noted down there, 3.3 meter, correct? This is 3.3 meter. Correct or not? And this width is 2.25 meter. This is 2.25 meter. If you remember, this is your L1, this is your L2. Correct? One confirmation. L2 so paikada banta. L2 visible. Okay, I shift this side. It slightly has gone out of board. Okay, no problem. That can be rectified. Okay, now okay. This is L2. Not going. Actually, such stains actually upsets me. Okay. This is L2. L2 equal to, see, just now I told, forgotten, 2.25 meter. 2.25 meter. And your column is here. Your column is here. Out of scale, This side is 0.2, this side is 0.6. And also, okay, you know this projection and this, actually projection point of view, both should be equal. There's some reason is there for explaining. Okay. Now, this lengthwise projections are 1.35 meter each. This is 1.35 meter. This also 1.35 meter. Whereas this is a plan actually, remember, fully out of scale. The widthwise projections are 1.025 meter. I will make some concept clear now only because later when we enter the real practical case of design of footing, when column from column you get not only axial load, 100% every practical design M1 and M2 will come. There we have to worry about something else like pressure variation and how to fix the footing dimension so that maximum pressure, see here pressure is constant, maximum pressure does not exceed SPC, and also there is no lifting. If it is purely axial load, no lifting. Who will lift it? So when this M1, M2 are there, it is possible that one side may get lifted and one corner will be critical. So at that time, I do not want to waste time unnecessarily once again to tell all these things. There also, because of the non-uniform pressure, loading pattern will change. That upward pressure pattern will change. But basic concept will remain same. Like what? Like bending moment calculation after BM over, fixing the depth, then increasing due to shear, calculation of reinforcement, checking for shear, all will remain same. Okay, now see. Now, you consider lengthwise bending. If you remember, if I put a sketch here, it will come like this. See, projection you can see here. I don't have to write once again. This is 600. There is a upward load of, I'll put it somewhere here. This upward load is 134.68. It is WP upward pressure 134.68 kilonewton per meter square. Remember, it is uniform pressure, very important. Uniform upward pressure. That's why UDL. Okay. Then, if I see from this side, what you can see? You can see smaller side of the column. Actually, this is vertical plane. This is also vertical plane. Why? We cut here. We cut here. Look from that side. If that is not clear, better not you study the subject only. Why? If that much is the confusion, it is not advisable to go for structural design. Dangerous person. You will be a danger to society. Okay, then, sorry for harsh word. Yes, if this is vertical plane, this is, some will tell horizontal plane, means danger to society. Right? Such people should not design. Okay. This also is same. See, this also is same pressure. Okay, now, projections are here. Now, see, you remember, already I told earlier, just to understand right here. See, for lengthwise bending, your reinforcement is like this. Write it, no problem. See, I will put here sketch. This is 12 torr at somewhere, yes, there, 125 center millimeter. For widthwise bending, reinforcement is like this. This is 12 torr actually require, see, here you require 12 torr 125. The required spacing there is, if you take 12 torr, based on bending, required spacing may be around 200. Still we gave 135. Tell the reason. Still we gave 135. Tell the reason. Actually, based on bending, here this is the real requirement. You need this much. There, requirement may be 12 or at 200. You can put a 200 spacing. Still we provided bar closer. Reason. Video blur. No, video is not blur. Sorry. Same problem of who is commenting video blur? No. Same thing. You are not changed to 480, I think. See, change to 480. Change to 480. Don't try to save data. Don't try to save data. Use the data for a good purpose, not for other unwanted purpose. Okay. Tell the reason now. What is the reason? I can see the video not good means I can see here. What is the reason? Tell the answer. What is the reason? Actually, this bending is for a overhang of or projection of 1.35. 1.35 square will come in bending moment. This projection is 1.025. 1.025 square will come. Actually, this bending is 70% more than that bending. So, the steel required here is around 70% more than that one. If you require 100 here, you require 170 here. So, if you provide 170 here, you need very lesser steel. You require around 100. But you are nearly giving around 160. Tell the reason. Minimum steel. IS code told less than that you cannot give because of minimum requirement. It happens. Sometimes what happens is this may be 12 torr 135. This may be 12 torr at 60, 70 will come. In that case, you have to go to 16 torr. 16 torr may come at around what? 100 etc. Very, very high steel. Sometime I will give an example later for you. Once this question is over, I will give a practical example. What happened in the site? There, one side heavy bending. I will tell you now only. Later I will forget. Due to some reason, this was near MS Ramaya Hospital. When I went for seeing the foundation, see, I saw the foundation like this, isolated foundation, and this is the foundation. See, a huge column. See, this projection and these projections are nearly 2.5 meter. This project around 2.5 meter. This projection is only around 1.1 meter, 1.1 meter. So this steel requirement, see, the steel required here is very high. Steel required here is very less. Here they are given maybe 12 torr at around 125 center to center. Whereas this steel, you may not believe, it was 25 torr. 25 torr at 100 center to center. Anybody can tell me 25 torr at 100 is how much times of this steel? Tell the answer. If you take this steel as one unit, tell me 25 torr at 100 is how much time of this steel? How much times? Tell the answer. How much times of that steel? Bega. Use common sense. I got it. Tell me, answer. 25 torr at 100 is how much times of that steel? If that is 1 rupee, how much is this one? How much times? Bega. Little common sense required. How much times of that one? This one. Then I will tell you what actually happened there. I will tell you in the site what happened. I will not tell further. I saw the steel. Luckily I saw it. Then it was rectified. Which place, where all, I will not tell, because why? Who knows? Somebody from that building, if here, they get frightened. Oh, this column foundation, one person told he rectified. If other columns are same way, how can we stay here? Too much of time you are taking. You calculate and tell me 25 torr at 100 is how much times of this steel? These, see, if you go to interview, if such questions are asked, if you struggle this way, they will tell you have no knowledge. So these are all inbuilt knowledge. This you cannot get by practicing or studying. 25 torque at 100 centered center is how much times of that steel? Stop. No answer, nothing. If you don't answer, I will not continue. If you don't answer, what I can do? Such a simple question. See, this is common sense answer. Someone in the high school, if he thinks, he can get the answer. If he thinks, you should tell him, here 12 torque diameter rods are placed at 125. Other way, 25 torque steel rods are placed at 100 center. He will calculate, and a good, intelligent high school student will answer. Right. Stopped. If you don't answer, what I can do? At least little apparent. Okay, if you don't know, tell me. I will tell the answer. Leave it. Why you waste time? If you don't know, at least tell don't know. But it is frustrating to know that, to see that don't know symbol, don't know statement. Stop there. For no reason, this is what you are doing. When you come to the 5.42, correct, congratulations. Yaro, Preetham, congratulations. It is 5.42, 53, 47, 222. 5.42, congratulations. 5.42 times of that one. How much steel you provide here? The steel we provided here is 5.42. If the cost of this item is 1,000 rupees, cost of this is 5,420 rupees. That way is there. Now, I will tell what happened. When I looked down there, to my horror, I found reinforcement like this. When I looked down, to my horror, I looked there. I was not in design field. I went for some inspection, something, I don't remember why I went, maybe 15, 20 years earlier. I looked down, got the shock of my life. I will tell you what he has done. He has placed, see, drawing, I will tell you why it happened. He has placed 25 torque at 100 here, and then he placed this way 12 torque at 125 center. Tell me, correct or wrong? Is the placing of steel correct or wrong? Is the placing of steel correct or wrong? Is the placing of steel correct or wrong? It is not only wrong, it is a criminal offense. Why? 100%. When the column is loaded, when centering or removed, then within no time it will get cut here. Suddenly, because of bending and shear, it will get tear off. The foundation will break. But building sometimes will still stand. Why? See, sometimes what happens is, in some buildings, see, this is a site. I have seen people providing column, see, for a column coming here, I have seen they provide footing here. Have you seen or not? Not combined. No connection with other column. Independently, they provide footing. When I was taking class in Hanumannagar area, neighbor building, as I was going every day up and down, I can see. Every time I used to wonder, what is going on here? Have you seen this way? Edge column. They provide fully eccentric footing. Nowadays they will not do because designer will not provide. Yes, this footing will lose contact with the soil. 100% that building, I know it. These columns, footings are useless. If you cut the footing, nothing will happen to the building because the footing existing there, it is as good as cut. But why building still there? Because when this column cannot take the load, as footing, you cannot transfer the load, then that column will not be a compression member. It will be simply a hanging member. That joint where beam and column is there, this is just a hanging member. So load will get redistributed and go to other columns. And because of the high factor of safety, building is somewhat standing, but dangerous. The very purpose of structural design is completely lost here. Why you don't bother? Here, this one, the column is around 200 by maybe 750 or 800. It is a 6-story building, I think. Now, 100% it will get cut. But still, because of the other columns, redistribution of load, building may stand or building might have collapsed. Tell me, why it happened? Because bar bender, brilliant person. In case of RCC slabs, if you remember, see, RCC slabs, usually high reinforcement this way, less reinforcement this way. Tell why? When the ratio, when one side is too long, other is short, this slab will be designed as what slab? Tell me. This slab will be designed as what slab? When one side is too long, maybe this length is around 5 meters, this only 2 meters. When one side is, when the ratio is more than 2, the slab is designed as what? The slab is designed as what? You know, earlier ETABS batch, this question is only for those who are in the regular batch. Designed as one-way slab. In one-way slab, bending will take place in the shorter span, along shorter span. So heavy steel comes in the shorter span, distribution bar will come here. This bar bender got a brilliant idea. He saw the drawing. He saw one steel 25 torr 100, other steel 12 torr 125. Maybe in the drawing sheet it is tilted. See, it is tilted. So he told his boys, along shorter, see, he saw only that much. One steel 25 torr, see, maybe in the drawing sheet this is tilted. He told them, see, shorter span, you know it now, gottu, heavy steel, 25 torr 125 and 100, this way provide 12 torr 125. That is for a two-way slab when all round support. In footing, there is no ratio. Here bending depends on the projection. Heavy projection here. See, this will bend very heavily. Very heavy bending, very heavy shear. This will bend lightly. Therefore, major mistake. See, this is because of bar bender thought. He always knows what? Longer span, usually for footing, equal steel they provide. This is a rare case. Maybe this is because this width is restricted there. That is our case. This width is restricted. So other side, they are given more. They should have given what? 25 torr 100 here. See, they should have provided reinforcement here for this one. Lengthwise 25 torr 100. Widthwise they should have given 12 torr 125. Then on that day, I informed, someone came, they agreed, they saw the drawing, and then removed the steel. And because when you remove the steel, what will happen? These short bars are not sufficient for this way. Why? Bars are already cut. This is cut for 2 meters. You need 5 meter length of bar. You can't join the bar, place this way. So they put new steel and concreted. Place I will not tell, near MS Ramaya Hospital. Maybe 20 years earlier. I did not study. I just looked down and saw the steel. And I looked this way as if some snake is there. Steel. So therefore, structural engineer should think. Not blindly. See, you design by software. Okay, agreed. But if you want to design by software, you should have good structural knowledge. Without good structural knowledge, if you learn only software, you cannot become a successful engineer. Maybe in the design office, you can do work, you get good salary, expert in software, but they will not depend on you. Okay, now, come back here. This question. Now you are checking for one-way shear. See, for our slab, if I remember, I made a note there, our capital D was 675 millimeter, and small d, actually for this bar and this bar, d are different. For safer side, we considered constant d, that is lesser d, 600. Actually 601 came, 600 will do. Why? 1 rupee lesser we take, safer. These all I told you earlier. Which is advantageous, you consider lesser, safe. Which is disadvantageous, consider lesser. Then danger, like what money you are getting, good. If you imagine less money coming, good for you. If you imagine more money will come, danger. Expenses are not good, expenses are bad. So if you think expense will come more, you are safe. Why? You will prepare for it. If you think expense will come lesser, if you think hotel is cheaper, fully eat it. Then if the bill comes more, you are in trouble. So you always imagine you have lesser money in the pocket and bill will come more, and never imagine you have higher money in the pocket and bill will come lesser. This all I told you, money matters. But this idea should naturally come. When someone asks me, a column is there, effective length is 6 meter, 6.28 meter. Shall I take 6.5? I tell, oh, what purpose? Design. Okay, take it. Okay. Somebody want to construct a column. He will ask me, column I am constructed, I am increasing the floor height. It was earlier decided that column height is 3.5 meter. Now I am making it 3.8 meter. I told, no, you cannot do it. Danger. During design you consider 3.25 meter. Now you are increasing the column height to 3.8. Danger. But if the column height is 3.38 meter or 3.5 meter, when you design, if you take 3.8, save. This all I told. See, for this, you don't have to think. It should naturally come. It should come naturally. You should not think, I consider column to be, then that means you are not knowing concept. Okay, now, leave it. See, one critical section here. Critical section here, actually not required. I'll take critical section here also. What distance? D equal to 0.6 meter. Why 0.6 meter? Because when you calculate, these are in meter. If it is 0.6 meter, tell me what are these two lengths first. What are these two lengths? Bega. Projection is 1.35. Critical section, this is the critical section right here. This is no space right here. Okay, everything. D equal to 0.6 meter. You write here. This is your critical section for shear. Tell the answer here. Projection. How much projection? This is 0.6 meter. This is 0.6. So what is that projection? Ashtot beka projection here. 0.75. 0.75. Okay. I will do one thing. I will write here. This is 0.75 meter. Same way here. This is 0.75 meter. Okay. Come here. Critical section is here. This is at D. D equal to 0.6 meter. This is also D. D equal to 0.6 meter. Therefore, tell me what is this projection. From 1.025 subtract 0.6. Answer. From 1.025 subtract 0.6. ಇಷ್ಟೊತ್ತು ಬೇಕಾ? ನಾಳೆ ಬರಲ್ಲ? ಒಂದು ತಿಂಗಳು ಬಿಟ್ಟು 0.425 meter. ಇಷ್ಟೊತ್ತು ಬೇಕಾ? 0.425 meter. Remember, we need outside distance. Why means I will tell you. Over. This is the critical section for shear. Now, this is critical section shear for lengthwise bending. This is for widthwise bending. Okay. Now you have to check for shear. Start. Now, what I will do is, I will tell some important concept for you now. See, this projection is 1.35. You should make a note. All these note you have to write today. This projection is 1.35. This projection also 1.35. Therefore, shall we check on the right side or left side? Remember, when you find bending moment, what BM came here, same BM came here. Why? Equal projection. Not only equal projection, upward pressure uniform. So, shall we check on either both the sides or only one side? Tell me. Shall we check on both the sides or only one side? Shall we check both the sides or only one side? No, shall we check both? Only one side. Okay, start. First, right statement here. Consider lengthwise bending. That means your critical section is star. This star. Critical section is this star. Okay, star. Start. Shear force V equal to, I told you 1,000 times how to find shear force. When cantilever action is there, see, whenever there is a cantilever action, any loading, if you want shear force here, if you look that side, it is this much load. If you look this side, you have required support reaction. Therefore, this first of all, wasting time. Already told you. Because some newcomers are there. At least let them learn. For a cantilever in footing all, when you want shear force, always look, tell me, right side or left side. I told very clearly. For shear force calculation, always consider for the from the section, left side or right side. First, left side or right side. From critical section, for shear force or bending moment, anything. For both BM and shear force, consider left side or right side. First. Istu late madadre, how to conduct the class? Retry. You are not telling. Here, when I want shear force here, shall I look, or wherever is the section, shall I consider left side or right side? No, wrong. You should not tell that way. Here you look right side, here you look left side, or technically write what? Don't write left side, right side. Technically write what? Tell me. Technically. Those who are not knowing, you should enter all these things. Make all these notes. Technically, correct word. Consider which side? Consider free hand side. Right? Consider free hand side. So, when I find shear force here, consider free hand side. Shear force is nothing but only load. So, 134.68 kilonewton per meter square means, I told class after class, it is not kn per meter square. It is kn per meter for 1 meter strip. So how much it is? 134.68 into 0.75. That is the total load. That's all. Keep quiet. Over. Suppose you want a bending moment here, that load into 0.75 by 2 will come. See, like earlier, when we found bending moment here, at the face of the column, 134.68 into 1.35 into 1.35 by 2. Answer first. This is shear force for working load. Answer. Tumba late ಮಾಡ್ತೀನಿ ನೀವು. Little fast you tell. This is a shear force for working load. See, you see how much I am explaining repeatedly. You get a person, something already told, and explain again and again. Why? Because inside my mind I feel some will have difficulty, maybe they won't understand, confusion is there. So, no problem. It will increase by number of hours. I am not going to sacrifice anything. 101.01 and 1 ರೂಪಾಯಿ 1 ಪೈಸಾ ನೀವೇ ಇಟ್ಕೊಳ್ಳಿ. 101 ಕಿಲೋಮೀಟರ್ ಸಾಕು. ಆ 1 ಪೈಸಾ ಯು ಓನ್ಲಿ ಕೀಪ್ ಇಟ್. ಯಾರು ಕೊಟ್ಟರು? ಪ್ರೀತಮ್, ನೀವೇ ಇಟ್ಕೊಳ್ಳಿ, ಪರವಾಗಿಲ್ಲ, ಆಯ್ತು. ದಿಸ್ ಈಸ್ ಫಾರ್ ವರ್ಕಿಂಗ್ ಲೋಡ್. ದೇರ್ ಫೋರ್ ಗೆಟ್ ಫ್ಯಾಕ್ಟರ್ಡ್ ಶಿಯರ್ ಫೋರ್ಸ್. VU. What is the answer? 101 see, for shear force, sign convention is not required. Remember, 101 into 1.5. This is 151.5 kilonewton. Correct? 151.5 kilonewton. Correct answer? Okay. Now, calculate. Shear stress. Shear stress means actual shear stress. Actual developed. Which IS code foolishly called nominal. Which IS code foolishly called nominal. I will use the same word. I will tell them the word nominal. Learn English and print IS code. Okay. That is tau V. This is real stress. Remember, tau V is the danger. Why? Stress is more is bad. Tau V equal to VU by BD. And when the load is taken in kilonewton per meter square, but when you took it as kN per meter, your breadth is understood 1 meter or equal to 151.5 10 to the power 3 divided by 1000 divided by D is 600. Good answer. Therefore, tell me what is the shear stress tau V developed stress. This is the actual stress. Answer. ಇವತ್ತೇ ಬೇಕು. ಇವತ್ತೇ ಬೇಕಿತ್ತು, ನಾಳೆ ಅಲ್ಲ, ನಾಟ್ ಟುಮಾರೋ. 0.253. 0.253 is the shear stress. Okay. Now we want what? Now we want tau C. To get tau C. Tau C means allowed shear stress. Allowed. See, tau V is bad. Tau V is bad. Tau C is good. Tau V is like the bill, how much you have to pay. Tau C is like how much money you have in your pocket. Tell me, you need what? You need percentage of tension reinforcement provided for lengthwise bending. That is PT provided. PT provided equal to 100 into AST provided. AST provided for what? For lengthwise bending. Remember, it is 12 torr at 12 torr at 125 center. But that you cannot use. We want AST provided. That is understood. Divided by BD or equal to 100 into. Now I am not going to explain for those people who are my regular students. I told thousands of times, if you know the spacing, how to find the total steel. Others, you try yourself. If I tell everything, keeping in mind others, this class cannot be done. It is 1000 divided by 125 into pi by 4 of 12 square. If this is your personal, this is, I told so many times earlier, area of steel provided, if you know the spacing is width considered divided by spacing provided into area of 1 bar. It is ulta of spacing calculation. Divided by 1000 divided by 600. Fast answer. Answer fast. This I will not explain. Someone will tell, sir, everything is clear. This is not clear. No, do not go to practical design. If you cannot get this answer, you don't know anything about structures. Again, danger to society. Sometimes I had to put harsh comment. Danger to society means, danger to medical field means what? Doctor does not know which medicine to give. He will take randomly something, injection, and provide. 1.1508. Okay. 0.1508. No unit. Okay, now start. From IS code, table number 19 for M20 concrete, PT and tau C. For 0.1508 lies between 0.15. Actually, they told what? They told if the percentage is what? Less than or equal to 0.15, tau C. How much? Tell me. If the percentage is less than or equal to 0.15, tau C. Bega. M20 concrete. For PT, either 0.15 or lesser. Bega, bega, bega. Bega. Istot beka. Nale barla. IS code table 19, M20 0.28. 0.28 what unit? Newton per mm square. Okay. Whereas if it is 0.25, ನಾನು ಹೇಳ್ತೀನಿ 0.36 ನನಗೆ ಗೊತ್ತು. Therefore, for PT equal to, what is the answer? 0.1508. Tell what is tau C. Tau C is the allowed stress. Actually, you don't have to interpolate. Wait, what? Oh, I forgot one thing. You can use Excel. Oh, forgot it. You can use Excel. Yes or no? Okay, you can use Excel. I forgot it. How much? Anyway, interpolate. Interpolate and get the answer. Actually, interpolation not required because your shear stress is 0.25. It has to come more than 0.28. So you can conclude there only. When you want to spend 200 rupees, when you want to give somebody 400 rupees or when you start counting the money, the moment you see 500 note, keep quiet. Don't count further. Suppose I want to give somebody 100 rupees. See, I'll take out the money from pocket now. Oh, 200s are there. Okay, done. But if I have to give 1000 rupees, then I have to count. And when I have to give somebody, say 890 rupees, if I see 500 notes, don't count further. 0.28064. ಅಷ್ಟೊಂದೆಲ್ಲ ಬೇಡಪ್ಪ, ಅಷ್ಟೊಂದು ಆಕ್ಯುರೇಟಿ ಬೇಡ. 0.2806. 2806. Therefore, your tau V, that is the actual stress, which is found to be 0.253, is less than, oh that's good, is less than tau C. This is good. That is the what? Allowed stress of 0.2806. Therefore, safe or not? Tell me answer. Safe or not? Bega, bega. Is it safe or not? Conclusion. Tell me safe or not. Safe. Safe. Leave it. Safe means leave it. Remember, some is bound to ask who came to today's class. If unsafe, what to do? See last time question. Last time question it came unsafe. I corrected. This time, see, after getting depth required, I did not increase by 75%. I increased almost what? Tell me. I did not, if requirement of depth is 100 or 300, I am not given around 75%. How much I gave? Keeping in all the shear problems, I gave how much? Tell me. Keeping in all this one, I gave how much? Not 75% more. How much I gave? To be safer side, tell me. How much bending point of view, whatever depth you got, when you provide depth, I gave how much? I gave 100% more, double. By giving double, all this trouble will be taken care and design becomes safe. See, now very safe. If unsafe, see, marginally unsafe means you can provide it more steel. Too much of unsafe means danger. Don't go for artificial, increase the depth. Now, those who got Excel sheet, what you do? How I told you to prepare Excel sheet, you type VU value 151.5 and then type other required values, then see the Excel. Excel will tell you tau V 0.253, tau C 0.28, or a ratio will come. If you give ratio of what will come? Of 0.901 will come, means actual stress is only around 90% of allowed stress. The bill is around 90% of the money. You are safe. It will come that way. Over. Now, lengthwise bending check over. Now, consider widthwise bending. This you should do now. Right now you have to do it. Start. Consider widthwise bending. See, I'll start once again now. Refer this sketch. Instead of 0.75, take 0.425. And instead of what? 12 tor 125, take what? 12 tor 8. Tell me. Instead of 0.75 here, take 0.425. And instead of what? 12 tor at 125, take how much? 12 tor 8. How much? 12 tor 8. Instead of 12 tor 125, take 12 tor 8. 135. And one more thing will happen there. There, your percentage will come less than 0.15. I will tell you. Here, when you calculate percentage, I will tell you, it will come. Let's come to percentage. It will come 0.1396. It will come 0.1396. Therefore, it is less than 0.15. Therefore, no interpolation. Directly tell the value of tau c. No interpolation. Why? It came less than 0.15. Tell me answer. Directly tau c equal to. Bega. What is tau c equal to? No interpolation. Tau c equal to 0.28. No interpolation. Tau c equal to 0.28. So now 1 hour non-stop talk. So I will do one thing now. Widthwise bending. You check right now. Check right now. Check right now. I will come back here and change the numbers and match it so that later what I will do, I will come back here, I will rub everything and change it to new one. Maybe just if you give answer fast, maybe question of 2-3 minutes. Start. Don't waste time now. Go for widthwise bending. You don't make fair copy. Why? Because when I come back, not I am going anywhere. 5 minutes. When I come back, I will change this one so that later you can take screenshot. Right now, you only rough sheet perform the check. First. Agreed? Only rough sheet perform the check so that when I ask, you give me all the answer. Agreed? First tell me. Agreed or not? Not agree. Agreed? Sometimes it happens. If I take a small break, some will vanish. Those people, I will tell, not my students. People who attend once in a while, not understanding everything, coming for jolly purpose or time pass, in between. Okay, let me see what case I is telling now. Don't come to the class. If you come to the class, be serious. Okay, start. Don't waste time now. Maximum in 5 minutes, I will come back. I will study something and come. Okay, for your information. Both come with me. Now I am entering what? Non-uniform pressure and load with the M1, M2, the most critical part. Start. You start now. As usual. Fast, tell me the values. Don't waste time. Tell me the values fast. No time waste. 1 minute. See, instead of 0.75, it is how much? I will use a red color here for cutting the values, but you should not do that way. You should write once again. I will use full red color to cut the previous values. It is 0.425. Answer, how much shear force? Shear force, ಎಷ್ಟು? ಇಲ್ಲಿ ಗೊತ್ತಾಗ್ತಾ ಇಲ್ಲ. I can't make out. You tell the shear force. 57.24. 57.24. Now, 57.24 into 1.5. Answer. 57.24 into 1.5. I will either cut or I will rub and write. 85.86. Then 85.86 divided by this one. Answer. Tau v. You can use Excel later. You can use Excel later. Excel is there with you. How much? Percentage. 0.143. And PT 12 tar at 135 center. So here it is 135, not 125, 135. Percentage. I told you percentage, how much? 0.1396, correct? Therefore, no table. Why? Directly write as per IS code for PT less than or equal to 0.15, tau C directly equal to 0.28 Newton per mm square. Therefore, tau V is 0.1396, tau C is 0.28, therefore safe. Over. Fully clear? This is so therefore remember the last question I told you, if unsafe comes, what to do? Medium unsafe. I gave an example for you. If you eat in a hotel, if the bill comes to suppose say some 600 rupees, if some 30, 40, 50 rupees shortage is there, you can request the owner, he will tell you give next time. But if you eat for 1000 rupees and tell I have only 600 rupees, he will not agree. Then you have to what? Increase the depth and check again. When you increase the depth, once again punching shear check is not required. And steel will reduce. The required steel will reduce. Some people what they will do is, they will maintain the same steel. Okay, that is there. But one thing, minimum steel if you are given, you have to give more. Why? When you increase the depth, minimum steel will become more. That you should be careful. Or you calculate once again steel. Anyway, practically you are not doing it because these are all Excel is doing, not Excel, software is doing. Software, you can give a command there. It will ask you, do you want to consider minimum steel? If you tell yes, what will happen? Whenever the required steel is less than minimum, it will give you directly minimum. So therefore, you don't have to bother in software. There is a inbuilt in the software library, there is a provision is there. Activating minimum. That's all. Okay, now, this is fully clear. See, lengthwise bending, widthwise bending. Now, one small important concept I want to tell now. See, make a note. Okay, this full I will remove now. Yes, everything can be removed. I do one thing. Use little water. Just wait for 2-3 minutes. We are changing over now new part or the closing part. New part or closing part of the isolated footing. the ink quality. Sometimes ink quality is so good that you touch my hand, it will go. Sometimes you have to struggle to rub it. What to do? See, this strain salt, it gives irritation. If it is still there, it gives irritation. So I won't remove it. Wait for 2-3 minutes and make the board clean. Otherwise, when I write something, those marks all gives irritation. Like you wear a very good shirt and then put some unnecessary dirt part there. How odd it looks. Okay. Now, some note you have to make. I will tell what is the note. Everything you require, what all I am telling now. Okay, now for this portion, little disturbance is okay. See, now sometimes when you apply axial load, due to some reason, footing, the column may not be perfectly concentric. It may not be perfectly concentric. See, for some reason, the column would have shifted here. See, this is the center of the footing. Center of the footing, for some reason, see, the column is shifted here. So the column center is here. Means, this is called what? Concentric or eccentric. This is called concentric or eccentric. First, this is called concentric or eccentric. This is called eccentric. If it is eccentric, what will happen is, the load is acting here. When you consider CG here, it will give a load P. Because of this eccentricity, it will give a moment this way, M1. And because of this eccentricity, it will give one more BM here, moment M2. Actually, it will come this way. Okay, no problem. This way. So it will become a case of axial load with the M1, M2 once again. And make a note. Design principle will be same as what you are going to cover now onwards. Because why? Then design principle is design of column footing when column is transferring axial load with M1, M2. I can't call every time one moment this way, M1, M2. M1 is lengthwise, M2 is widthwise. It can be this way, no problem. Okay, then the pressure variation will not be uniform. It will be non-uniform. And we consider linear variation. I will tell you a little later about that one. Okay. Further, in such cases, the pressure will be non-uniform. So what to do is, see, once you consider the design part here, see, I will tell you, when you design, for example, imagine a column footing here. I will give an example here, remember, and I will write now only. Very, very important. Very, very important. Make a neat fair copy. Neat fair copy with all the explanation I am going to tell in the class. And further, little later, when I go for the numerical part of design, these concepts I will not explain. I will not explain this concept. I will tell, thoroughly explain. Or you can do one thing. You write in a neat format and pin it. Or entire thing, write in a box format. Right? Required for design when P with the M1, M2 are there. Okay, start. Now, I will take there is one case. There is second case. Column is concentric only. Actually, remember now, make a note. If the column is eccentrically placed, too much eccentricity is not allowed. See, for example, if the column is eccentrically placed this way, eccentrically placed, then for design purpose, what you do? You take the column to be concentric only with what? M1, M2. Therefore, once again what? When you consider P, Actually, P acting here will be shifted here. So finally, P will come here only. Now, this is P and also one lengthwise M. I will call M1. This M1 and one more M here. That I will call M2. Now what will happen is pressure will be non-uniform. See, if I take this as A, this corner B, this corner C, this corner D, column center is here. So even if the column is eccentric, remember when you consider M1, M2, tell me load becomes what? When you consider M1, M2, eccentric load is shifted to CG of the footing. Then what happens now? So when you consider M1, M2, then P is eccentric or axial. Once you consider M1, M2, then your P will become axial or eccentric. First. Once you consider M1, M2, your P becomes axial or eccentric. Not answering. Huh? What is this? Once you consider M1, M2, then what I can tell? How to take the class? How to take the class if I tell that way? Once you consider M1, M2, P becomes axial. Clear? Who told eccentric? Pritam ji. How? Eccentric load is shifted to CG of the column. Okay. Or imagine you have some irregularity in the house. Some violations are there. So it is eccentric case. You are not, it is as per the bylaws. So you are in trouble. Why? Problems are there. But if the BBMP comes, makes a survey and finalizes everything and they put a fine to you, once you pay the fine, tell what? Your house is fully legal or still illegal. Once you pay the fine, once the fine is paid fully, is it legal or illegal? From then onwards. Now I cannot change. Sorry. Now I cannot change. Some corrections are coming. 57.24. No. I correct. What happened? Correct answer. Why so late you are giving answer? Correct answer. I took 57 point something only. I took 57 point something only. Why correction now? Now it is not allowed. Tell me answer. Once you pay the fine, it is legal or illegal? Earlier illegal. Once the fine is paid, it becomes legal. Or imagine college, you are very irregular. Attendance shortage is there. They will tell you cannot write examination. Then there is a solution. You request, produce some certificate, tell some lies. Tell some lies only. I was not well, you are well. You are always enjoying outside still. And then they put a fine. Once you put the fine, you get admission ticket. When you go to admission ticket, they don't write their attendance shortage. You are like any other person. Therefore, now it is axial. See, now, these two projections need not be equal. Why? Because if these two projections will depend whether column is what? Concentric or eccentric. If column is really concentric, these two, then M1, M2 will come some other way. See, M1, M2 will come from some other way. That is the moment transferred from column. Your column is resisting not only axial load, bending moments are there. That one. So, if the column is really concentric, projections are equal. But remember, projections are equal, but pressure is not equal. Pressure is varying both ways. Or, if by chance the column is slightly eccentric, then the projections are not equal. Clear now? Projections are not equal. Clear or not? But remember, all these design you don't do manually. SAFE will do it. Okay. Now, do one thing, consider the case. See, I will write once again here now. Right now I am clarifying. Why? Later I do not want any confusion. I cannot keep on shout like this for class after class. What calculation I am giving now is permanent solution when pressure is non-uniform. Right here. When pressure is non-uniform, I am giving solution. See now. You take example of a column. You take example of a foundation. I will tell you, very, very important now. This is a numerical example to make complete clear. Then imagine your column is this way, somewhere here. For some reason, this projection is not equal to this projection. Just imagine, no harm in imagining. This projection is not equal. I'll put one thing. This is it lesser I will make. Okay. This is this way. This is the column. Now, just imagine this projection is 1.445 meter. This projection is 1.65 meter. Just imagine. Just imagine. You write. Let the length L1 I am not giving. Why? I don't require. And imagine this projection and these projections are not equal. This projection is 1.45, 1.65, 1.35 meter, and this projection is 1.55 meter. Okay. Imagine this is the arrangement. Clear now? I will tell you why I am giving arrangement. Tell me fast. Imagine this is the arrangement. Arrangement clear? First, I will require more space here. I will manage it. Arrangement clear or not? Why comments are coming now for shear? I don't know. Why comments are coming for shear? You are not telling clear or not? Clear. Okay. Now, see. Pressure diagram required. See now. You consider, see now, consider lengthwise bending. Okay, this is arrangement now. I will do one thing now. Start. Consider lengthwise bending. I will write here now because I am going to remove everything now. You consider lengthwise bending. 1 minute. I should see that it is within the board. Hope it is not outside the board. Why? There is a problem there. Why? Because, why what happened? I paused there, then I am back, little backward. Okay. Where I wrote? Okay. Consider lengthwise bending. See correctly. When you consider lengthwise bending, see, your same sketch I am writing now, your sketch is like this. Not to scale. Not to scale. I got space problem here. Same sketch I am telling. Column is somewhere here. Column is here. Don't buy heart that way. Left side is more, right side is lesser. Don't buy heart that way. I am giving a very thorough example for you. Okay, this way. See now. Lengthwise bending. Now, for lengthwise bending, see this way, you have to take a strip of 1 meter. Imagine your 1 meter strip is coming here. This is your 1 meter strip considered for lengthwise bending. This is the 1 meter strip considered for your lengthwise bending. From column center, either side you are taking. Okay. Now, below, I will project here now. See, lengthwise bending means, see here. I will write the pressure diagram here. Pressure diagram. Imagine this pressure is net pressure. All the pressure are net pressure. Net pressure. Although 168.9 kilonewton per meter square. Random number. Why I am telling? Because when I do the problem, if I explain there, I need more space. It will eat, the space will not be there. So it is called preparing everything. Tomorrow's function suite, today only you are preparing. Okay. 168. And imagine pressure here is lesser for some reason, not 168, 141.6, all first decimal, kn per meter square. It goes this way. Okay. Now, see, correctly tell me now, or I want the length now. For some reason, I want the length. The length is, or this column side, 1 point. Imagine this column side is 0.75, this is 0.3. So this length is, I want some reason, the length. Length is 1.65 plus 1.45 plus 0.75. That length is 3.85 meter. Okay. Now, these are the projections. Now see, if I take the entire length of what? 3.85 meter, then this is the pressure diagram. Now, when you consider lengthwise bending, cut here, you are seeing column like this. Tell me, what column side you are seeing? Tell first. What column side you are seeing? First tell me. When you see in front, cut it here. This is a plan. In the front view, what column side you are seeing? I will make each and every concept clear now. Remember now, if anybody does not follow here and think that it is an imaginary problem, later I will study real problem, you will be in serious trouble, because in the real problem, these all I am not telling. I will write the sketch here and walk out. I will tell. Based on my earlier explanation, get all the values. I may take half an hour break. I may take half an hour break. I will tell you, finalize everything. No, I did not go through. Then leave the class. Leave the class. If you don't follow what I tell, then leave the class. That will be my ultimate guideline. 0.75 meter. Okay. Now, you can see like this. Okay. And remember now, this projection is lesser. How much? 1.45. This projection is more. Very, very important. This projection is more. And this is the footing. And now, just imagine your D equal to, small d equal to, I do not want capital D. Just imagine your small d equal to 0.65 meter. Common. Because later some D will come. Okay, now see. Now, if I see here, there is a cantilever here. If I see here, there is a cantilever here. Why I am explaining? Because everything to be made clear now. Cantilever either side. Now, if I draw the pressure diagram for this cantilever, see, this cantilever projection is how much here? Only there, 1.45 meter. This cantilever projection is 1.65 meter. Imagine, actually, make a note. Our class example, our column will be concentric. Therefore, in our class example, both will be of equal projection. If such a thing happens, you don't do manually, let the SAFE do it. Okay, now, tell me. Now, tell me, I want, see, here, this is the upward pressure diagram. You never bother now. See, this 141.6 and 168.9, you write, he told, we believed. But when I do real design, these values you have to get. So when I solve the problem, real design, I will correctly come up to here. I will get the pressure here, I will get the pressure here. Then I will walk out. I will walk out and tell, now continue and get the bending moment. Okay, now, see, therefore, see, full length is 3.85. Here to here is 1.65. Here to here is 1.45. For some reason, I want the pressure here. I want the pressure here and I want the pressure here. These two pressure, ಇದು 1.45 meter, ಈ ಕಡೆ ಜಾಗ ಇಲ್ಲ, 1.65 meter. These two pressure you have to get by linear interpolation. I will use red color. Tell this pressure and tell this pressure using linear interpolation. Fast answer. This I will not explain. If anybody got difficulty, what you have to go to YouTube, my as under the name Mathematical Concept Tricks and Shortcuts. There, class number 3 in the playlist you can see Mathematical Concepts. Class number 3, I completely wiped out any difficulty for linear interpolation. Remember, more than 1 hour. I gave financial matter. I gave example of financial matter also. Anybody will go through that class number 3 in mathematical concept, in lifetime, he will not have any difficulty for interpolation. Answer. Then, now do one thing. Left side not visible. Ayo. 1 minute. Left side, I made it visible earlier. Okay. I slightly tilt it. Tell me. Now left side, fully visible. Okay. I tilted it. Now, 1 minute. I will check the battery. See, battery level is 43. Don't forget, after half an hour, to remind me for recharge. Or I will put recharge now. Now means I had put the plug. After half an hour, I will explain something. Or once I finish this part. No. Now tell me. Now fully visible. Okay. I don't want to take chances. Because you may not remind me. You may not remind me. I will also forget. Then suddenly, what will happen? It will get switched off. Suddenly it will get switched off. Then again problem. Why? I had rescheduled the class. Again, I had to give I had send the links all. I do not want that one. So, I will put the charging. Because I don't believe you. Sometimes you tell, yes, we will tell you, but you forget then. Okay. Now charging going on. Do one thing. Do me a favor. Around 8 o'clock, remind me to remove the charging. Why overheat unnecessarily? Because by that time, remaining time, charge is sufficient. Now how to go there? 1 minute, see. When I came here, now to go there, I had to remove the wire. If I go as it is, it may pull somewhere, and again you will tell, this side is not visible, that side is not visible. Okay. I should be very careful for moving here. This all can be solved by a proper way of setting. How will tell? Sir, you tell this always, you never do it. What to do? Habit. Now, fully visible now? No, not replacement theory. Replacement theory. Yes, is it fully visible now? Board. Completely. Fully visible? No. Is the board fully visible now? You earlier told not visible. You answer it. Okay, start. Now, fast, tell the answer. By interpolation, what? See right here, this red color values are, see right here, red values are by linear interpolation. Answer here. If you take this much time, difficult to take the class. Tell the answer here. This is 141, how 141.6 and how 168.9, how 1.65, 1.45, how 1.35, 1.55 came, it will come in the problem. But this I will not explain. This I will not explain. 158.62, second decimal saku. Nodi, one person answer, I cannot depend, because after 10 minutes, somebody will tell that is wrong. I cannot repair this one once again. At least one more person should give. Otherwise, what happens is, after some time, someone will comment, sir, that one is wrong. That becomes frustrating then.
ಇಷ್ಟೊಂದು ಕಷ್ಟ ಇದೆಯಾ? $156.62, 158.62. Congratulations. This is 158.62 is this ordinate. This ordinate is it 153.3? Correct answer. That ordinate is 153.3. Correct? Okay. Congratulations. Congratulations. Over. Start. Now, this is a cantilever. This is a cantilever. If the load, everything I am going to tell you should write if you want to learn. I cannot tell every time. Everything I talk in the class has got value. I don't just tell, even if I give financial example, there will be some reason for it. See. Now, one cantilever this side, I am considering only lengthwise bending. One cantilever this side, one cantilever this side. Both the cantilevers are here not of same projection, different projection. But when I do a problem later, it will be same. Because if such thing happens, you do in the safe only. Okay, now, shall I consider both the cantilever, or one side cantilever is 1.65 and other side cantilever is 1.45? See, 1 minute. And tell me, shall I consider both side cantilever to be safer side and find BMSF both sides and take the higher value? Shall I see, when you give steel, a common steel, you don't give separate steel here. See, full lengthwise steel. So design purpose. Shall I consider both sides separately and then for each side find bending moment and shear force later and then consider the higher value, or directly consider one side? Tell the answer. Directly consider one side and other side. See, last time when the projections are equal and pressure is uniform, you consider only one side. Tell the answer here. Shall I consider only one side or both sides? First answer. I have given example, critical example for you. To take care of the structural knowledge, I have given critical example. Shall I consider both sides separately or only one side will do? Both sides are required. Tell the reason. Both sides required because write what all I am telling. If I see right side, projection is lesser. If I see left side, projection is more. Therefore, from projection point of view, tell the critical. Right side cantilever is 1.45. Left side cantilever action is 1.65. Therefore, if you consider the projection point of view, tell me which is critical, right or left side? If I consider projection point of view, critical is left side. But right side cantilever has higher pressure, left side cantilever has lesser pressure. Therefore, if I consider the pressure point of view, the loading, the pressure is nothing but loading. If I consider loading point of view, tell the critical. Left side critical or right side critical? Left side critical or right side critical? If I take the loading point of view, which side critical? Right side high pressure, left side less pressure. Right side critical. Oh, this is problem. Why? This will, left will tell I am more critical than you because my projection is more. But right will tell your projection is more correct, but your pressure is lesser. I am subjected to high pressure. So we cannot tell, we cannot decide which side is critical. Therefore, cannot decide which side critical cannot decide which side critical. Therefore, better consider both sides. Consider both sides and then consider higher bending moment, higher BM and SF. Tell me, this is for lengthwise bending. This is for lengthwise bending. Tell me, fully clear or not? This is for lengthwise bending. One has, see, clear, okay. Now, same way, I will not tell once again, if I now only write, same argument, even for widthwise bending. Reason, notice, one side projection is 1.35, other is 1.55. So, when you take widthwise bending, from projection point of view, the front side is critical, that is back side. See, front side critical, but pressure point of view, I am going to give pressure diagram like this. I am going to give pressure diagram like this. Means what? Tell me. Tell me. That means from projection point of view, tell me, back side critical or front side critical? First, from projection point of view, back side critical or front side critical? From projection point of view, I am going to give like that, back side. But from pressure point of view, which side critical? From pressure point of view, back side. From projection point of view, back side. Yaradu? Nandakumar. This is 1.35 back side, front side 1.55. From projection point of view, front side is critical, but pressure point of view, back side critical. Oh, here also same problem. So you have to consider both. Tell me fast. Clear or not? Clear or not? Fast tell me. Clear or not? I will make everything clear now. Everything comment should come. Okay. Now only make a note. Now only make a note. For or 1 minute. Now only make a note. This is the time to make the note. You write, hey, bending, you wait for some time, I'll come. By chance, your footing is like this. I'll tell you here. Your footing is like this. This is randomly 1.6 meter. This is 1.5 meter. And pressure is like this. Pressure is like this. Tell the answer. When you take lengthwise bending, you should write separate note here. These all you have to make a separate note. You tell the problem. I will continue later. Let me discuss something and come back. Those who are serious will write. You hold the problem. Hey, wait for some time. I will come to you back later. Start. Tell me. From projection point of view, I am considering lengthwise bending. Projection point of view, right side critical or left side critical? Projection point of view, here. 0.75. That's 0.75. That's 0.75. What is 0.75? E dimension alla. Don't see these dimensions. Random dimensions. Right side critical. Projection point of view, right side. And tell me, from pressure point of view, which is critical? From pressure point of view, which is critical? Projection point of view, right side critical. Pressure point of view. Answer. Pressure point of view. That also right side critical. Therefore, here you write from projection point of view, right side critical, pressure right side. Therefore, here you consider this side. You need not consider this side, because what BM and SF you are getting here is 100% more than BM SF here. So, here If one side is, it can interchange, don't buy heart now, it can happen other way. So, where projection is more, if pressure also is more, then outrightly that side is critical. Clear or not? Then outrightly that side is critical. So other side you need not check. Waste of time. Tell me fast. Fast. Clear? Okay. Now, same argument for widthwise bending. Shall I explain widthwise or not required? Tell the answer. Shall I once again give an example of widthwise or not required? Widthwise bending. Shall I put one more random sketch or explain or not required? Your choice. If you want, I will put high projection here, less projection here, high pressure here, low pressure here. Tell me, required or not required? You can write yourself only. Widthwise bending, not required. Okay. Now, make one more note. But practically or for next question, what happens is, for next question, this projection will be equal to this projection. Say 1.5 meter, not 1.5, random. This projection and this projection are 1.45 meter, 1.45. Now, pressure diagram comes this way. Here, pressure diagram comes this way. I will take care of that way. That I will see it. I will see those things. You don't bother. Okay, now tell me. Projection point of view for both lengthwise bending, either side equally same. Widthwise also, projection will not count. Why? How much this cantilever, same this cantilever. How much this cantilever, same this cantilever. So, you need not bother about projection variation. Tell yes or no. You need not bother about projection variation. You should see only what? You should see only what? You need not bother which is critical based on projection. Why? Both are equal projection. Equal. Hey, projection, you are not under discussion. So, you should see only pressure variation. So, 100% for lengthwise bending, right side critical or left side critical. Tell the answer. For lengthwise bending, right side critical or left side critical. Fast. 100% for lengthwise bending, right side critical or left side. Right side is critical. For widthwise bending, tell the answer. Back side critical or front side critical. For widthwise bending, back side critical or front side critical. Widthwise bending, back side critical. Over. So, when I take up my example later now, when I do a problem, a column of so and so, subjected to so and so, when you get the pressure, I will just tell in the class, remember, I will just tell in the class, lengthwise bending, both are equal projection, but see the loading, that side more pressure, so you consider for lengthwise bending, right side part, and when you take widthwise bending, see the projections are equal, so projection does not matter, both are equal. Therefore, see the pressure is more that side, so back side cantilever you consider for design. I will tell that much and walk out. Why? Walk out because in the class now, I am demo example, I am giving only one side or both sides. Tell me. There you require only one side. Which one? I will tell you right side. See, I am explaining now. Therefore, in the problem, when I walk out, tell me. Here, I am considering both. Why? Worst case. Can you continue? Tell me. At that time, can you continue or not? I will be careful. At that time, can you continue or not? No. Can you continue? Yes. So therefore, I will tell only one word at that time. Now I am taking a little long break because I will bring to this level, ready for calculation. The sketches I will write, then I will tell. I will come after half an hour. You consider lengthwise bending, get the bending moment, look right side only, don't look left side. Consider widthwise bending, look the back side or front side, I will tell you, and calculate and get ready. I will give enough time and I will tell you, if not clear, leave my class. I will tell that way. Leave my class. I do not want you to study from me. Not fit to be my student. I will tell that way only. Okay. Now, this is fully clear. Okay. Now, all this note you write, then write. Now, once again come back to our example. Nodi, illi bani. You tell all these you write separately for understanding purpose. Okay, then all this over. Now you write, let me continue the example. Okay, start. Come back to example. We just now decided that either side you have to check, yes or no. Projection point of view, left side critical, pressure point of view, right side critical. So in one way, that in one aspect, this is critical. In other aspect, that is critical. Oh, one journey, travel cost is more, food expense is lesser. Other journey, travel cost is lesser, food expense is more. Oh, you can't tell. You can't tell. Sometimes it will happen. One journey, travel cost more, food also more. Other journey, travel cost less, food also less. Then undoubtedly, you know the critical. But one journey, travel cost is more, food is cheaper. Other journey, travel cost is cheaper, food expensive. Which is critical? You can't tell. You have to check it. Tell me. Finally, these basic concepts fully clear. Make each and every note told by me. Each and every note told by me you should write. You are lazy, don't write properly. If not clear, you have to pay the penalty. Okay, now start. See, one cantilever here, one cantilever here. This length is 1.45, this length is 1.65. And one more thing, I will draw the pressure diagram. When I consider this cantilever, you consider only this much pressure. When I take this cantilever, consider only this much pressure. Therefore, I should sit down now and write. ನೋಡಿ ಸ್ವಲ್ಪ ಜಾಗ ಇಲ್ಲ, ಅಲ್ಲಿ ಸ್ವಲ್ಪ ತಿನ್ ಮಾಡ್ತೀನಿ, ಯಾಕೆ ಜಾಗ ಇಲ್ಲ ಅಲ್ಲಿ. ಸಾಕು ನೋಡಿ, ಈಗ ಕೂತ್ಕೋತೀನಿ ನಾನು, ನೋಡ್ಬೇಡಿ. ಐ ಡು ನಾಟ್ ವಾಂಟ್ ಫುಲ್. ಮೈ ಕ್ಯಾಂಟಿಲಿವರ್ ಈಸ್ ಹಿಯರ್. ನೋಡಿ, ಮೈ ಕ್ಯಾಂಟಿಲಿವರ್ ಈಸ್ ಹಿಯರ್, ಒನ್ ಕ್ಯಾಂಟಿಲಿವರ್. ಮೈ ಅದರ್ ಕ್ಯಾಂಟಿಲಿವರ್ ಈಸ್ ಹಿಯರ್. Other cantilever is here. This is little bigger, this is smaller. This cantilever, the pressure here is 168.9 kilonewton per meter square. And pressure here, this pressure, 158.62 kilonewton per meter square. This is the pressure variation for right side cantilever of length 1.45 meter. If I come to left side cantilever, my pressure here is 153.3 kilonewton per meter square. Here lesser, it will come this way, of here 141.6 scale gilla kn per meter square. This is my second cantilever. Now, pressure diagram. Okay, now, this is for lengthwise bending. Now see, bending moment point of view, critical section, one section here and one section here. This I will call critical section on right side. This I will call critical section, 1 meter. Critical section for BM on right side. This is critical section for BM calculation on left side. I won't write full. Critical section for BM on right side, critical section for BM on left side. Start. This diagram, I want once again, I will make a note here, 1.35, I will forget later, 1.55, take a screenshot, 0.3, take a screenshot. Later, I will ask you these dimensions. I am removing now. See, later I will tell you, one cantilever this way, one cantilever this way. At that time, or I can write here only. Okay, little later, consider width-wise bending. At that time, you can see like this. Okay, now, 1 minute. Before that, I want the pressure variation. I will give you later. If I look this way, cut it. Pressure was there. Before that, I should give the pressure value here. I write pressure value here. Pressure value is here more, here lesser. Ether pressure. This is the upward pressure. E pressure. Randomly I am giving. 141, 168. 168. 178.9 kN per meter square. ಒಂದು ನಿಮಿಷ ಆಯ್ತು. ಇಲ್ಲಿ ಯಾರೋ ಅಂತಾರೆ 160, ಇಲ್ಲ 168 ಅಲ್ಲ, ಬೇರೆ ಬರುತ್ತೆ. 154.8. Do not bother. See, this number need not be this number. There is a reason. You never bother. You imagine. You tell these values he gave. What he gave, we will believe. Ashte. He told it, it will come later. Okay, now, see, correctly. This is 1.35 meter, this is 1.55 meter. Full length is, tell me the full length. Oh, anybody can tell me the full length here? Fast. Anybody can tell the full length here for me? 1.35 this side, 1.55 this side. Anybody can tell me full length here? Agata? 13, 15, 15, 20, 28, 29, 3.2. ಅಯ್ಯೋ, ಇಷ್ಟೊಂದು ಕಷ್ಟ ಇದೆಯಾ? 3.2. 3.2 meter full length. Now, tell me, for some reason, later I want pressure here and also pressure here. Ready? That is where the column face is there. Why? Because I will put a sketch later. I want what? I want critical section to pass here for bending. So at that time, I want this ordinate and also I want this ordinate. Tell the answer. What is this ordinate? I will put one more sketch for you. And later, see, 1.65 is not required for me. I will put one more sketch. 1.45. ಅಯ್ಯೋ, ಇದು ಬೇಕು. ಬಿಡಿ, ಈ ಥರ ಇದೆ, ಪ್ರಾಬ್ಲಮ್. ಈಗ ಸ್ವಲ್ಪ ಜಾಗ ಪ್ರಾಬ್ಲಮ್ಮು. ಈ ಕಡೆ ಬರ, ಹಂಗೆ ನೋಡಿ, ಇಲ್ಲೇ ಅದೇ ಥರ ಬಡಿತೀನಿ. ಪ್ರೊಜೆಕ್ಷನ್ ಆಮೇಲೆ ಬಡಿತೀನಿ, ಪರವಾಗಿಲ್ಲ, ಆಮೇಲೆ ಬಡಿತೀನಿ, ಪರವಾಗಿಲ್ಲ, ಬಿಡಿ, ಆಯಿತು. ಟೆಲ್ ಮಿ ಆನ್ಸರ್. ವಾಟ್ ಈಸ್ ದಿಸ್ ಪ್ರೆಷರ್, ವಾಟ್ ಈಸ್ ದಿಸ್ ಪ್ರೆಷರ್ ಆ್ಯಂಡ್ ವಾಟ್ ಈಸ್ ದಿಸ್ ಪ್ರೆಷರ್ ಬೈ ಇಂಟರ್ಪೊಲೇಷನ್? ಬೇಗ ಬೇಗ. ಇಲ್ಲಿ here 154.8, that is for 3.2 meter. From here to here is, ಅಯ್ಯೋ ಫರ್ಗಾಟ್, ಎಷ್ಟು ಹೇಳಿದ್ದು ನಾನು? 1.55. ಅಷ್ಟು ಬೇಗ ಮರ್ತೋಯ್ತು. 1.55. ದಿಸ್ ಈಸ್, ಐ ಟೋಲ್ಡ್ 1.35. ಚೆಕ್ ಮಾಡ್ತೀನಿ ಬೇಗ. ಐ ವಾಂಟ್ ದಿಸ್ ಪ್ರೆಷರ್ ಬೈ ಲೀನಿಯರ್ ಇಂಟರ್ಪೊಲೇಷನ್, this pressure also by linear interpolation. Answer. ನನ್ನ ಕೈಲೇ ಮಾಡ್ತಿರಲ್ಲ, ಇದೆಲ್ಲ ನೀವು ಮಾಡಬೇಕು. You need not bother how this number came because it will come later. ಈಸ್ ದಟ್ ನಂಬರ್ 168.31 ನನಗೆ ಗೊತ್ತಿಲ್ಲ. ಈಸ್ ದಿಸ್ ನಂಬರ್ 168.31 kn per meter square and this number 166.96 kn per meter square. ಹೇಳಿ ಕರೆಕ್ಟ್ ಆರ್ ರಾಂಗ್? ಟೆಲ್ ಮಿ. ಐ ಓನ್ಲಿ ಡಿಡ್ ಇಟ್. ಟೆಲ್ ಮಿ ಕರೆಕ್ಟ್ ಆರ್ ರಾಂಗ್. Interpolation values. I do not want later write again. ಯಾರು? ಬೋತ್ ರೈಟ್ ಪ್ರೊಜೆಕ್ಷನ್ ಆ್ಯಂಡ್ ಬೆಂಡಿಂಗ್. ಏನು ಗೊತ್ತಾಗ್ತಾ ಇಲ್ಲ ನನಗೆ. ಬೋತ್ ಈ ಕಮೆಂಟ್ ಅರ್ಥ ಆಗ್ತಾ ಇಲ್ಲ. ಬೋತ್ ರೈಟ್ ಪ್ರೊಜೆಕ್ಷನ್ ಆ್ಯಂಡ್ ಬೆಂಡಿಂಗ್. ರೈಟ್ ಅಗೈನ್. ರೈಟ್ ಅಗೈನ್ ನನಗೆ ಗೊತ್ತಾಗ್ತಾ ಇಲ್ಲ. ವಾಟ್ ದ ಕಮೆಂಟ್ ಅಂತ. 168.73 ಇನ್ನೊಂದು 166.4. ಚೆಕ್ ಮಾಡ್ತೀನಿ ಬನ್ನಿ. ಚೆಕ್ ಮಾಡ್ತೀವಿ ಬಿಡಿ. ಅದೆಷ್ಟದು? 178 ಚೆಕ್. ಪ್ರೊಜೆಕ್ಷನ್ ಕರೆಕ್ಟ್ ಆಗಿದೆಯಾ? 1.35 ಪ್ಲಸ್ 1.55 ಪ್ಲಸ್ 0.3 ಈ 3.2 ಕರೆಕ್ಟಾಗಿದೆ. 178.9 ಮೈನಸ್ 154.8 divided by 3.2 is the ratio. I will store in calculator. Then that rate into 1.35 I subtract from 178.9. 168.73 ಬಂತು. ಓ ಸಾರಿ. I think I made some calculation mistake. It happens. 168.73 ಇದು 168.73 ಈ ಕಡೆ that rate into 1.55 plus 154.8 166.47. ಈಗ both are correct. Tell me. If you tell something else, I can't make out what you are telling. Upper side 168.73, lower side 166.47. Why not required? Why not required? Someone told not required. Why not required? Tell the reason. You told not required. Why? No required. This projection is lesser. This projection is more. So this side bending you have to consider. Why not required? Yaro not required andru. It is not required if the pressure is lesser and the projection also is lesser, not required. But here required. I told just now. Both sides you have to check. Both sides, because why? One side pressure more, other side pressure lesser. Where pressure more, projection lesser. Where pressure lesser, projection more. Both are required. Okay. Now see, if I write the same way, you can see a cantilever here. ನೋಡಿ ಈ ಥರ ಬರೀತೀನಿ. ಇಲ್ಲೊಂದು ಕ್ಯಾಂಟಿಲಿವರ್, ಇಲ್ಲೊಂದು ಕ್ಯಾಂಟಿಲಿವರ್ ನೋಡಿ ಈ ಥರ. ಈ ಲೆಂತ್ ಇನ್ನೊಂದು ಬಾರಿ ಬರಿತೀನಿ ನಾನು. ಈ ಲೆಂತ್ ಎಷ್ಟದು? 1.35. ಐ ರೈಟ್ ಒನ್ಸ್ ಅಗೈನ್ ಹಿಯರ್. 1.35 meter. This cantilever length is 1.55 meter. And now if I take a cantilever here, take a cantilever here, or if I take a cantilever here, this cantilever will have a pressure of ಇಲ್ಲಿ 178.9 kN per meter square. When it comes here, it will reduce to ಸ್ವಲ್ಪ ಕಮ್ಮಿ, ಸ್ವಲ್ಪ somewhat scale. ಒಂದು ನಿಮಿಷ. ಬೋರ್ಡ್ ಕಾಣ್ತಾ ಇದೆಯಲ್ವಾ? ಈತ ಬೋರ್ಡ್ ವಿಸಿಬಲ್? ಫುಲ್ಲಿ ವಿಸಿಬಲ್. ಓಕೆ. ದಟ್ ಈಸ್ 178 ಆಯಿತು. ಇಲ್ಲೆಷ್ಟು? 168.73 kN per meter square. This is the pressure diagram for the back side cantilever, and if I take the front side cantilever, this pressure is 166.47. ನಾನು ಎಲ್ಲ ಬರಿತೀನಿ ನೋಡಿ. kN per meter square. ಇಲ್ಲಿ 154.8 kN per meter square. It is this way. This is the pressure diagram for the bottom side cantilever. And nodi, I write here. This is your critical section for bending moment on back side. ನೋಡಿ I won't tell once again. This is my critical section for bending moment on front side, and your strip will run somewhere here. This is where, ಈ ಬೆಂಡಿಂಗಾ, ಸಾರಿ, ಯುವರ್ ಸ್ಟ್ರಿಪ್ ವಿಲ್ ರನ್ ಸಮ್ವೇರ್ ಹಿಯರ್. ನೋಡಿ, ಗೊತ್ತಾಯ್ತು ನನಗೆ, ನೋಡಿ ಕೂಡಲೇ ಗೊತ್ತಾಗೋಯ್ತು. ದಿಸ್ ಈಸ್ ದ ಸ್ಟ್ರಿಪ್. ಅಷ್ಟು ಗೊತ್ತಾಗೋದು. ದಿಸ್ ಈಸ್ ಯುವರ್ 1 meter ಸ್ಟ್ರಿಪ್. ಹಿಯರ್ ಸ್ಟ್ರಿಪ್ ವಿಲ್ ರನ್ ದಿಸ್ ವೇ, ಹಿಯರ್ ಸ್ಟ್ರಿಪ್ ವಿಲ್ ರನ್ ದಿಸ್ ವೇ. ಸೊ ಎವ್ರಿಥಿಂಗ್ ಈಸ್ ರಿಟನ್ ಹಿಯರ್. So far, everything clear? Fast. So far, each and everything clear means I will go to DM calculation for one of the cantilever. Remaining you have to do. Ittu matadidira. Okay, start. Now make a special note. Make a special note. Special note. I won't tell once again. See, randomly consider a cantilever. Don't by heart left or right side. See, and if UDL is there, say WP is there, projection is P, then bending moment here equal to WP into projection is the total load into projection by 2. And if I take a shear section here, shear post there means total load this side. Clear? Same way, any cantilever. If the pressure is UDL, uniform pressure, the bending moment equal to, see, total load into distance up to center. Fully clear? This is what you had done last time. At least one more I tell clear. ಗೊತ್ತಾಗೋದು ನನಗೆ, ಹಳೆ ಕ್ಲಿಯರಾ ಹೊಸ ಕ್ಲಿಯರಾ ಅಂತ. If UDL is there, it will be WL square by 2 if you want. Total load is intensity into length by 2. ಆದರೆ ಬರೀ, but in case pressure is not uniform, randomly varies, no, and make a note, any side can be more, any side can be lesser, don't by heart. Then imagine pressures are different here. Different. Say this pressure is P1, this pressure is P2. Pressure I am telling. No, pressure, you P and projection alla. Okay, this is called WP1, this is called WP2. W last time uniform. Which is more, which is less does not matter. Which is more, which is less does not matter. ಈಗ if this is the case, if the projection is P, if the projection is P, then bending moment here equal to, it is not UDL, it is UVL. And remember, this WP will be in Kn per meter square. Even if it is Kn per meter square, it is actually what? Tell me. Even if it is in Kn per meter square, it is actually Kn per what? Answer. Even though you write in Kn per meter square, it is actually Kn per meter per meter strip. Now, if it is UDL, constant value. Now, remember, in case the load is UDL, total load equal to intensity into length passes through center. Whereas if the load variation is trapezoidal, then tell the answer. Total load equal to, fast answer. Total load equal to, answer. Total load equal to, if it is trapezium, total load equal to, formula. If it is trapezium, total load equal to, ಇಷ್ಟೊತ್ತು ಬೇಕಾ? If it is a UDL, intensity into length. If it is trapezoidal loading, then loading diagram is there. Whenever loading diagram is there, you write here. Whenever a load is uniformly varying and represented by a diagram, then total load equal to, ಬೇಗ total load equal to, ಬೇಗ ಹೇಳಬೇಕು, ಇಷ್ಟೊಂದು ಲೇಟಾ? If load is represented by a diagram, total load equal to, ಎಷ್ಟು ಬಾರಿ ಹೇಳಿದ್ದೀನಿ ನನಗೆ ಗೊತ್ತಿಲ್ಲ. ನನಗೆ ಫಾರ್ಮುಲಾ ಬೇಡ, ಐ ವಾಂಟ್ ಟೆಕ್ನಿಕಲ್ ನೇಮ್ ಬೇಕು ನನಗೆ. ಅದು ಆಮೇಲೆ ನೋಡಿ, ಟೆಕ್ನಿಕಲ್ ನೇಮ್, ಟೋಟಲ್ ಲೋಡ್ ಈಕ್ವಲ್ ಟು ಅದೆಲ್ಲ ಆಮೇಲೆ, ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಲೇಟರ್. ಅಯ್ಯೋ, ಇಷ್ಟೆಲ್ಲ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡಿಬಿಟ್ಟು ಇಷ್ಟೊಂದು ಕಷ್ಟ ಇದೆಯಾ? ಆಲ್ ಆಫ್ ಯು ಡೂ ಒನ್ ಥಿಂಗ್, ಗೋ ಟು ಯೂಟ್ಯೂಬ್, ಡಿಫರೆಂಟ್ ಟೈಪ್ಸ್ ಆಫ್ ಲೋಡ್ಸ್, ಮೇ ಬಿ ಕ್ಲಾಸ್ ನಂಬರ್ 13 14 15 16 ಇರಬೇಕು. ದೇರ್ ಫಸ್ಟ್ ಪಾಯಿಂಟ್ ಲೋಡ್, ಲೀವ್ ಇಟ್ ನಾವು. ದೆನ್ UDL, leave it. Then UVL by a triangle, leave it. Then UVL by a trapezium. See the playlist. SFDBMD 100 some 13 14 classes are there. Maybe you can see there. Maybe in the beginning, class number 11, 12, 13, 14 ಅಲ್ಲೆಲ್ಲ ಇದೆ. Introduction to different type of loading. Then point load, UDL, UVL. Then you can see uniformly varying load represented by a trapezium. Today only go and see that one. ಏನೇನು ಹೇಳ್ತಾ ಇದ್ದೀರಾ? ಇಷ್ಟೆಲ್ಲ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡಿ, ಇಫ್ ಯು ಸ್ಟಿಲ್ ಡೋಂಟ್ ಗಿವ್ ದ ಆನ್ಸರ್, ಸಿ ದೋಸ್ ಹೂ ಆರ್ ಪ್ರೆಸೆಂಟ್, nobody is telling anything. This is very bad. I told you, if whenever a loading is represented by a diagram, you should write everything. The total load will be always equal to. ಏನು ಮಾಡೋದು? ವಾಟ್ ಟು ಡು? ಐ ಡೋಂಟ್ ನೋ ವಾಟ್ ಟು ಡು. I feel like collapsing here. After explaining so much for my regular students, those who are newcomers, you are knowing first time. No, go back to SFDBMD course and study there and come back. ಏನೇನೋ ಬರ್ತಾ ಇದೆ. ಅಬ್ಬಬ್ಬಾ, ಫೈನಲಿ someone told total load equal to area of load diagram. Load diagram, remember, if it is pressure diagram, total load equal to area only if you take 1 meter strip. Yes, only if you take 1 meter strip. If you don't take 1 meter strip, that whatever you get, you have to multiply by the actual width. Adella beda. So anyway, don't bother. We take 1 meter strip. So for a pressure diagram, as long as you take 1 meter strip, close your eyes and tell total load equal to area of load diagram. Okay. Second point, and that total load will pass through what? Not center. That total load will pass through what? Not center. The total load will pass through where? ಇಷ್ಟೊತ್ತು ಬೇಕಾ? ಅಯ್ಯೋ, if I waste this much time, already YouTube told. Actually, this is the mistake I am making. By this time, I would have finished everything. Passes through CG of the load diagram. Passes through CG of load diagram. Therefore, if this is the load diagram, remember, if you consider the entire pressure, this is the load, this is the distance. So I will call this is capital WP, means resultant load. This is, I will call X bar. Then remember, I will tell only once. In future, not clear means don't come to my class once again. Don't come to my class once again. I should tell that way. Here, your WP, that is total load, equal to, you are right, area of this load diagram. You should write area of load diagram is area of a trapezium equal to sum of the two parallel sides. You write by, no, you go to YouTube class of trapezoidal loading, class number 17, 18, study and come back. Sir, we can't do it. Then leave my class. Over. Sum of the two parallel sides, WP1 plus WP2, divide by 2. Which 2? Standard 2. Multiply by distance between the two parallel sides, that is P. Sum of the two parallel sides divided by 2 multiplied by distance between parallel side, and center of gravity x bar you want from this side here. See, x bar from here, WP1. When you want CG from any one end, formula is that side plus twice of other side divided by that side plus other side multiplied by distance between the two sides divided by 3. Today only go and study. That's equal to, start from here, that side first, WP1 plus 2 times of, your finger should be here. Why? Where, from where you want distance, put the finger there. That side plus twice of other side, twice of WP2 divided by that side plus other side multiplied by distance between the two sides divided by 3. Fast, tell me. Clear or not? Bega, bega. If it will clear, little work I will give for you. High time, instead of shouting like this non-stop and spoiling my throat, I will take up one of the case, remaining 3, I will give for you, I will take rest. I deserve the rest. Okay, now you told clear. See, now one cantilever here, one cantilever here, one cantilever here, one cantilever here. Among these 4 cantilever, I will explain thoroughly one of the cantilever. Remaining, you can do it fast. Right now only. I will walk out. This all I will remove now. Remaining, can you do yourself only here only? Fast, tell me. I will explain any one. Remaining 3, right now I want the answer. Yes, start. Now, see. All over, come here. First, lengthwise bending. Okay, start. Lengthwise bending. One, you write, one cantilever this side, one cantilever side. I will first consider the right side cantilever. Or I will tell, see, section 1-1, section 1-1, section 2-2. Later, I will tell section 3-3. I will tell section 4-4. Okay, start. That is section 1-1. Start. Bending moment at critical section. Critical section. That is 1-1 equal to, start. Come here. Come here. Look this side. Uniformly varying load. Total load is 158.62 plus 168.9 divided by 2 multiplied by 1.45. This will give you total load. See, this will give you, see here, total load. I don't know where, somewhere here you get the total load multiplied by distance of CG of that load diagram from here. From here I want. So, this side first, 158.62 plus 2 times of 168.9. Don't by heart left side, right side. Plus what? 2 times of 168.9 divided by sum of the two sides, 158.62 plus 168.9 multiplied by distance between the two sides. 1.45 divided by 3 is the maximum BM in kilonewton meter, that is sagging BM. Answer. Hey, answer. That is going to be sagging BM. Isolated footing due to pressure, BM is always sagging. Therefore, you require bottom steel. You know it. You require bottom steel. ಇದು ಎಷ್ಟು ಬಾರಿ ಏನಾಯಿತು? Already told 1000 times. How much bending moment? Oh, shall I come after 1 month? 173.736. 173.736 is the bending moment. Over. Now, lengthwise bending, same way you consider left side. That is critical section 2-2. Correctly find the bending moment. Nodi. I will tell you here. Bending moment here. I should stand here now. Where? Here. 153.3 plus 141.6 divided by 2 into 1.65 into bracket 153.3 plus twice of 141.6 divided by 153.3 plus 141.6 into 1.65 by 3. Calculate. Now, later, once you finish, go for widthwise bending. First consider critical section 3-3. That is back side. Bending moment here. Answer. I'll tell fast. 168.73 plus 178.9 divided by 2 in 1.35 into bracket 168.73 plus twice of 178.9 divided by 168.73 plus 178.9 into 1.35 by 3. Look this side. Bending moment here. Look this side. 166.47 plus 154.8 divided by 2 into 1.55 into bracket 166.47 plus twice of 154.8 divided by 166.47 plus 154.8 into 1.55 by 3. Calculate fast. I will take rest. You type all values. Let me see. Some rest I will take. I told so. Some people can do one thing. They will go later, go to recording. Slowly they will play it in the slow mode. And you can do it. They will play in the slow mode, 0.25. Then I will tell 155. It comes that way. In YouTube, advantage is there. You can play in the slow speed at 0.25, 1/4 speed. How fast I told? 168.73%. It will come 168.73 plus 178.9. You can do it if you want. Stop. Do not waste time. If you type remaining 3 values in order, I will come and continue. Or I will do one thing. I will give all the values and go. You should tell you got it. ಅದಕ್ಕೆ 4 ಬೇಕು 4 ಬೇಕು Something went wrong. I don't know what is the calculate playing with me. ಯಾಕೋ ಡೌಟ್ ಇದೆ. I got a doubt about this value, you check it. I got a faint doubt about that value, you check it. What? I do not know when I am coming. When you type got all the 3, I will be back and explain to you the shear part. So that as I start the main question, I am not going to explain all these. Of course, on the board I am writing there. But this much I will not explain. Shortman. Start. Sometimes people, what they will do is, they will leave YouTube now, go to Facebook or WhatsApp and enjoy the time. Do it, no problem. That shows how serious you are. Instead of trying and trying to get the answer, they will think, oh, break is there, let me go somewhere else. I have seen that one. When I go to break, slowly people vanish. They again come back. That shows how much serious you are. Little rest I will take. Still lot of time is there today. No problem. Every principle will be covered today, including pressure variation also. That MP by A, M1 by Z1, all will come. I will tell you later how this pressure came, that all will come today. Ready? I'll start because I got there. Two answers got off. You know one thing. Why this much I am explaining? If you think you can make out. See, if I tell shortly, with not much explanation, don't tell repeatedly. People will tell, good, very good class, excellent. They will put that way. Very good. Comment will come. They will tell this person is very good or accept like that. No. I know difficulties. I know people making mistakes. So when I teach something, I want everybody who attend my class should get thorough idea. And second, people don't understand. After all, some 3-4 hours now, if you spend that correctly and understand, lifelong you won't forget. People become lazy, don't study properly. Instead of thoroughly studying for 3-4 hours, they may require 2 hours 100 times. Throughout life, they will have difficulty. Why? Not clear. So no patience. If patience is not there, my class is not for you. And once I start a class, I forget everything else. Okay, start. Now, I will write here now. Okay, now I can't remove this one now. Okay, I will write here. So, if not clear, it is your problem. If not clear, it is your problem then. I will remove everything now. This is 190. I removed everything. Okay, you tell me, is the same answer or not? What I told, same or not? Start. Consider this side, that is section 2.2. I will write using red color. See, bending moment here. Look this side. First, what I want? First, I want this total load, light line. This total load I want. 141.6. Bending moment I want. BM at critical section 2.2. Okay, I will use black only. Why? Ink is not there. Okay, start. Sum of the two parallel sides, 141.6 plus 153.3 divided by standard 2 into distance between the two parallel sides, 1.65. Remember, when you finish this one, this will give you total load into this distance. From here I want, so start from there, into 153.3 plus twice of 141.6 divided by 153.3 plus 141.6 multiplied by distance between the two sides is 1.65 divided by 3. This full term is distance from here to the load, equal to, you get kn meter. Tell the answer. Is the answer same as I have given? First. Is the answer same as I have given or not? First. Learn once in a lifetime. No, just tell me. Is the answer same as? Yes, okay, done. You know the answer. Write it. Now, other two, I won't write. I will dictate. See here. Bending moment here. Look this side. Total load this way. 168.73 plus 178.9 divided by 2 into 1.35 will give total load into this distance is 168.73 plus twice of 178.9 divided by 168.73 plus 178.9 into 1.35 divided by 3. Tell me, is the answer same as what I gave? First, is the answer same as what I give? If it is same answer, leave it. Otherwise, I will check it. I told some answer. Is it same or different? Same. Okay. Lastly, bending moment here for this side. See, I want bending moment here. So start. 156.47 plus 154.8 divided by 2 into 1.55 will give you total load into this distance I want. That distance is 166.47 plus twice of 154.8 divided by 166.47 plus 154.8 into 1.55 divided by 3. That way you make fair copy every time, right? This will give total load, this will give distance, full cantilever you have to see. Very important. When you do bending moment, from fixed support up to free end completely to be seen. Tell me, full clear or not? Because I will explain everything now. Later, no doubt. If it take little time, no problem. We are almost, see those who are in the ETAB batch, we are very near to software now. But just because very near to software, I cannot leave as it is. Clear? Okay. Now, make one more note. This is for bending moment. Lastly, shear force. When you check for shear, right? When you check for shear, remember, not punching shear. Punching shear you do like this. That is earlier. No, not punching shear. When you check for shear, that wide beam shear or one-way shear or shear causing diagonal tension, tell the answer. Critical section will be at what distance? Today only I am clarifying. No doubt later. Critical section will be at what distance? Start. When you do one thing, after everything is over, you once again write the sketches. For shear purpose, do one thing. Write the sketches once again. Very good for health. Critical section will be at what distance? Critical section will be at what distance? Fast. Oh, forgot, so fast. When you check for shear, critical section will be at what distance? D by 2. Abba, I told just now, punching Allah. Abba. So fast, if you forget means what I can do? At D from face of the column. See, write a note. Critical section will be at D from face of the column. Okay, start. Now, what you do is, you write the sketch once again, all the sketches. No problem. Learning means learning. Now do one thing. You mark, see, critical section, one here. One critical section will come here. One critical section will come here. One more critical section will come here. All of them at D 0.65 from face of the column. So right here, where from here to here is 0.65. From face, from here to here is scale illa. Ayo, so pay kade parli. I parabidi. Illige. This is 0.65. Or you can see here also. Illide. Critical section. Here also. From here critical section. This is 0.65. This also 0.65. So tell me, what is this length? This is 1.35. This is one more sketch you have to write. Not this sketch, why mix up will come. One sketch for bending, second time put the sketch. Once for all. Once you write neatly and understand, you can refer any time. One day struggle. Tell the answer. If it is 0.65, what is this length? Bega. Don't waste time now. 0.7 meter. Remember, calculated. If this is 0.65, tell what is this distance out of scale. This distance 1.55 minus 0.65. ಈ ಕಡೆ ನೀವು ತುಂಬ ಲೇಟಾಗಿ ಕೊಡ್ತಾ ಇದ್ದೀರ, ನಾನು ಮುಂದಕ್ಕೆ ಹೋಗಾಯ್ತು ಈಗ. If it is 0.65, what is this distance? 0.9 meter. Okay, still not over. Come here. If this is 0.65, what is this distance? Bega. 1.45 minus 0.65. Answer. 1.45 minus 0.65. Bega. Time waste mabadi. This already you know it. 0.8 meter. Okay. 0.8 meter. Here, if this is 0.65 critical section, what is this length? What is this length? ಇನ್ನೂ ಕೆಲಸ ಇದೆ. 1 meter. 1 meter. Okay. Now, remember now, I told you earlier, in case of a cantilever, if UDL is there, when you want maximum bending moment, full load. But when you want shear force here, only this much load. You should look free and side. Therefore, now you need what is this intensity, what is this pressure. You require what is this pressure and what is this pressure. You need all this pressure. By interpolation, you have to get this pressure also. You need what is this pressure, and also you need what is this pressure. Interpolation. So no time. I will directly give the answer. Okay. I will directly give the answer. You try later. I will give the ordinate directly now. You can once again come back here, get it. Shall I give directly? Interpolation. Okay. This will be 173.83 calculated value. Pressure only here. This pressure is 161.58 calculated value. This pressure is 163.23 is calculated. This pressure is 148.69. Sometimes people ask me, sir, adeng sir, ಬೇಗ ಬಂತು ನಿಮಗೆ ಹೇಳ್ಬಿಡಿ ಅಂತ. ಬೇಡ, you try your own way. ಆಯ್ತು. ಈಗ very careful. When you have a cantilever this way, if UDL is there, if I want shear force here, only this much load. How much? Intense in that length. But now you got trapezoidal loading. Therefore, when you want shear force here, look free and side, look free and side, look free and side, look free and side. Consider only load, no into. Only load means only what? Tell me. You want only load. If you want only load, only what? Tell me. Bega. If you want only load means only what? Abba. You want only load. Only there. Up to free end. Only load means only what? If you don't answer, I should close the class. Earlier we want bending moment. Now we want only load. Only area. From where to where? Area from critical section up to free end. So here only this much area. Here only this much area. You write one more sketch actually. Here only this much area. Only this much area. Okay, start. So I will write one thing now. I will call this as critical section as ಆಗ ಬೆಂಡಿಂಗ್ ಮೂಮೆಂಟ್ 1 ಇದೆ. I will call as 1-1-1-1-1-. This critical section I will call 2-2-. This critical section I will call 3-3-. This I will call 4-4-. Therefore, I will take only one of them for your lengthwise bending shear force calculation for 1-1-. Shear force V for working load is, look this side, only area 163.23 plus 168.9 divided by 2 multiplied by 0.8. That's all how you get the shear force. Tell me, fully clear or not? This is how you find shear force for that section. Tell me clear or not, fast. You tell clear, over. I am going to new part now. Clear. Now do one thing. Remaining, I will give answer for you. For which one? For 2 dash 2 dash, then 3 dash 3 dash, and 4 dash 4 dash, I will give answer. Okay. 2 dash 2 dash answer is, I will read here now, see. 141.6 plus 148.69 divided by 2 into 1. 145.15 kilonewton. For 3 dash 3 dash, from here, look that side. It is coordinate 173.83 plus 178.9 divided by 2 into 0.7. For 3 dash 3 dash, 123.46 kilonewton. For 4 dash 4 dash, look this side. 161.58 plus 154.8 divided by 2 into 0.9. 142.37 kilonewton. Over. Now, completely clear means tell me, I will rub the full board and go to column with axial load. Column is subjected to axial load with biaxial bending. That is the real practical case. Some clear should come. At least those who are present, 1 or 2 should tell clear. In case any calculation mistake is there, ignore it. If anybody comments later, you know what is my answer. Okay. Now, one thing forgotten, see, you should write. When you do lengthwise bending, one section here, one section here, you got 2 bending moment. Tell me, for design, which BM you have to consider? Same way, you got 2 shear force here. For design, which shear force you have to consider? 2 designs are not done. When you have double checking is there, tell me which value you have to consider. For design or for bending, 1 bending here, 1 bending here, 1 shear, 1 shear. Which one you have to consider? Which one you have to consider? Both you are not designing. See, lengthwise bending, 1 BM comes from that side, 1 BM comes from this side. 1 shear post that side, 1 shear post this side. Tell me which BM and which shear post you have to consider. Maximum values. That's all. Over. Okay, now start. Everything. All these principles. Everything told. Fully clear. I will clean the board fully now because why? Completely new part you are going now. Remember. Now you are going to completely new part. It will take 1-2 minutes for cleaning the board. At least how much I shouted should be worth. You should tell. Now so many things we learned which we are not knowing earlier. You are randomly knowing. Lot of doubts were there. If you make a fair copy of all these and go through once, sufficient. Just I will give a small example, but if I tell you, you will tell, oh, this person telling is knowing too much, not that way. See, there is a method called Carney's method. While rubbing, I will tell. Carney's method, if subjected to frames or without sway, derivation is very simple. But if a multi-story building, sway is there, and if fixed and hinged and both are present, and if lateral loads are there, not only at the joint, at other places, the derivation of the Carney's method for that one will take at least 4 or 5 hours. And around 30 equations are coming. And lastly, summary will be there. Maybe I remember one batch long I had done the derivation, then I stopped it. Not required. See. And for information, even I was also not knowing who is Carney before I finished my BE. During BE, I was not knowing who is Carney. Of course, when I reached 7th semester, I started getting interest in the subject. Then I came to know who is Carney. Okay. Then The derivation, I still remember. First time I took a paper and derivation was randomly given in the books, not fully all case considered. I analyzed that one and got the result. From that day up to today, I never bothered about derivation. You come now, ask me, I will derive. Why? I got confidence. I will derive right now. Around 30 equations, it will come. That shear condition, that correction factors, unequal height, all will come there. Not that I am good in remembering. By hearting, who will remember? That is, concept should be firm in the mind. It should be like swimming. See, I was considered expert swimmer when I was very young. Even now, I am an expert swimmer. But only thing is, I get tired now. I tried. Around 3-4 years earlier, when I went native place, full water, I jumped and from here to there, I was swimming. When I came back, I was panting. See, why? Age. But I am not bothered about swimming. Any water, I can jump now. It is a natural process. Okay, start. So these all, you should get confidence. Means you should think. Once you understand something, it should be permanent. Okay, start. Now, completely fresh. Remember, make a note. Real practical. Then some will ask you, sir, what is that one bogus, sir? No. Real practical means you are entering real practical design. Everything told so far is the foundation for understanding. Now you develop the real practical. See, that is for the footing, not only axial load, but also axial load is P, but also M1 and M2. Now, M1, M2 means one bending or couple this way, see, and M2 lengthwise. M2 is widthwise. This I told you for column chapter, or I will show you now. See, only once I will tell. Footing. See, footing. You should make a note. Axial load. Axial load will give compression. This way, moment or couple. It is not called bending moment. See, this way. It will try to lift this side, but push that side. One couple I will take this way. Anything will do. Either this way or this way. Design is same. Direction not required. I will take this way. Okay. It will push this side, lift this side. Clear? Therefore, axial load will give you uniform pressure. Bending, this M1, M2 will again give varying pressure because bending equation. So resultant pressure will vary everywhere below the footing. Clear now? These all you should write. I am dictating. What all I told you should write. Clear or not? No, clear. Okay. Now start. First you do one thing. You concentrate on pressure calculation. See, there are two types of pressure. Two, you know it. One is called gross pressure. Other is called net pressure. In gross pressure, we consider not only column load plus also extra what? Weight of foundation and also some filling all weight of foundation, which you can take approximately as what? Tell me. Which you can take approximately as what? You consider not only axial load but also weight of footing, because when you consider the soil, weight of footing also and earth filling also goes there, which can be taken as what? Approximately. Approximately. How much? ಅಷ್ಟು ಬೇಗ ಮರ್ತೋಯ್ತಾ? weight of footing and other things approximately can be taken as. You ishtond later, you are delaying a lot for giving answer. If you delay this much, which already you know, then I should not ask any question. See, then I should not ask any question. Keep on doing like a recorded class. It will become like a recorded class then. If there is no communication, and ಈಗ ಬಂತು 10% of axial load P, or if you are considering the total load transferred to soil, then the load to be considered is not P, 1.1 P. Tell me, clear or not? It is 1.1 P approximately. First tell me, clear or not? I'll give a small note now for you. Clear. But remember, when you go for SAFE model or ETAB and SAFE, you don't consider self weight of footing. Tell why? Reason. When you model, you are giving the length L1, L2. How to give will come now. And you are also assigning thickness of footing slab. Therefore, self weight of footing slab, you don't tell SAFE. Why? Tell me. You don't tell SAFE self weight of footing. Why? Reason. You don't tell it self weight of footing SAFE. Why? Tell me. Why you don't tell SAFE self weight of footing? You assign only column load. Don't give 10%. Why? Reason. Self weight of footing, ETAB will calculate. Clear now? It will calculate. So when ETAB will give pressure, it will consider not only column load, also weight. But if heavy earth filling is there, then you have to give extra weight. Suppose you feel 10% is not sufficient, little deep earth filling is there, maybe 20% required. If you feel 20% required, don't give. If you feel 22% required, don't give 22%. Tell how much? Tell me. Suppose you feel, including self weight and other things, maybe around 22%. Assign only how much? Tell me. Don't assign 22%. Assign only how much? If you feel 22% of P is to be assigned, don't assign 22%. How much? First. In SAFE, do not assign 22%. Self weight it will calculate. How much percent? Assign. Suppose you feel extra load is there. You feel whatever column load is there, 22% more required. Do not assign 22%. Ayyo, ಏನು ಇಷ್ಟ ಬಂದಂಗ. Assign only 12%. Why? 25. Where all you get this idea from? 22% you decided that 10% is the self weight, remaining 12% extra. If you feel 10% self weight and another 12% extra is there, in the ETAB/SAFE model, assign only how much more? Tell me. Don't assign 22%. Why? This is the rough. ETAB will calculate. Assign only 12%. Correct? But manual design, you assign 22%. Okay. Next. Second point. You should write. When you consider the safety of the soil, when you consider soil, tell me, gross pressure required or net pressure? Tell the answer. For checking the pressure with the SBC on, whether we do not want soil to be pressure on soil beyond SBC. When you want to check the pressure and want to ensure that it is not beyond SBC, shall we consider gross pressure or net pressure? First, shall we consider gross pressure or net pressure? This also I told you, you forgot. Because finally to the soil, not only column load, weight of footing also will go. ಎರಡೋ ಕಮೆಂಟ್ ಬರ್ತಾ ಇದೆ, ಅದೆಲ್ಲ ಆಗೋಯ್ತು. No. Shall we consider gross pressure or net pressure? When we consider what? Soil safety. ಆನ್ಸರೇ ಬರ್ತಾ ಇಲ್ಲ ನೀವು. ದಿಸ್ ಐ ಟೋಲ್ಡ್ ಯು ಅರ್ಲಿಯರ್. ಇಫ್ ಯು ಡೋಂಟ್ ಆನ್ಸರ್, I think I will stop the class then. Suddenly I will stop the class then. I may stop this way. If so many are there, nobody is giving answer. This I told you earlier. For the soil, what? Weight of foundation also counts. So therefore, when you want to ensure that soil is safe, you have to always consider gross pressure. And remember, ETAB also will find gross pressure. But when you find bending moment and shear force for the footing slab, at that time you should not consider gross pressure. Tell what you have to consider. I told you, when you consider bending moment, shear force, etc. for footing slab, at that time net pressure, that is at that time not 1.1 p, only what? At that time not 1.1 p, only what? Tell me. Only not 1.1 p, only what? Only p. Remember, therefore in the formula, if you write 1.1 p, it means gross pressure. Gross. If you write only p, it is net pressure. Remember. But ETAB will always do gross pressure. No problem. It will calculate net pressure. You don't have to tell ETAB. So in the ETAB model, when you go to pressure check, when you move the cursor, it will give gross pressure. So therefore, when you design by software, you move the button cursor in the slab and see, it will actually contours will be there. Actually, it gives the pressure by colors. One corner thick diagram will come, high pressure. That all I will tell you when you do software. Okay, start. And remember, what problem I am solving in the first class here, same problem I will take up later for software, so that you can compare the result. You will tell at that time, oh, parvailla, software also gives same answer which he wants. What I want, it will give correct answer. Okay, now, Nodiga. Basic principle. Imagine, see, you write here. Consider a footing. This is plan. Remember, this is plan. I am writing plan. Let it be L1. Let it be L2. 1 minute now. See, this class is for RCC batch and ETAB batch. RCC batch, I already told the bending theory. Yes or no? P by A, M by Z all. I already told in the RCC class. I did up to there. Tell me yes or no. Those who are coming for RCC. I told all the pressure variation, that P by A, M by I into Y, and axis, everything told. Tell me yes or no. Those who are coming for RCC. I told crystal clear how is the pressure variation equation, basic bending theory. Charging. Okay. Thank you. Charging I put to remove charging. No. Okay. I will remove charging. Better, because it may go for overcharging then. Danger. That is, it may become overheating. So suddenly something goes wrong, class will be curtailed. And I don't want mobile to be blasted also. Okay. Charging over. I will remove charging. But 1 minute, I will check it. Oh, no. Danger. Only 30% is there. No. Better not remove charging. It is showing only 30% because whatever charging it is getting, it is used for this one. And one more thing, at present my mobile, I don't know reason, it is getting slowly charging. Earlier it used to get fully charged in 1.5 hours. Now for full charging it takes more than 3-4 hours. Some maybe battery problem. So therefore, no, danger. I will maintain charging. No problem. Okay. Maybe at 8:30 I will remove it. Maybe because of battery problem. It's giving very slow charging nowadays. It takes around 4 hours to complete charge. Earlier, within 1 hour, it used to get fully charged. Okay, now, see, L1, L2. This is the center of the footing. Now, very, very important, I will not tell again and again. Tell me, this axis we are calling number, Bega. This axis we are calling number. I told you in the column chapter, even for those who are in ETAB and general public, I told very clearly, the axis parallel to L1, I am calling. Name, 1122, what I am calling? The axis which is parallel to L1, I am calling 11 or 22. Answer ಮಾಡ್ತಾ. In the column, I clearly told 1, 1. I'll use red color for 1, 1. I'll use red color for 1, 1 to differentiate. To correctly understand, I'll use red color. Idu 1, 1. Axis 1, 1. And I will use black color for 2, 2. Now, axial load will be here. Axial load P will be here. Remember now, 10% is not taken. When I explain the principle, I will take only axial load. Then I will tell you, if you want gross pressure, take 1.1 P. If you want net pressure, take P. So time being, you are in strength of materials. So there is no gross net P. Okay, then one moment will come this way. One more moment will come this way. Now, this moment, tell me, if I take 1, 1 here, tell me, what is this moment? Fast. It can be like this or like this, anything. I will take this way. Tell what is moment. Name. Is it M about 1, 1 or 2, 2? If this is the axis, if I apply this way, it is 1, 1 or 2, 2. It is M1. It is M1. And black color about this axis, it is M2. Or remember now, this is M2. M2. This I told you. See, this way, this is M. When you take this axis, this is M. When you go to Excel, you should be extremely careful. Okay. Now, this is L1, L2, P. Or, see, this is a plan. Or remember, actually it is like this. See here. This is a footing slab. Nodi. P. Tell me, fully clear or not? First, I will take the corner as A, B, C, D. Don't by heart A, B, C, D. I don't know. I think most probably I have taken those who came to RCC. Tell me, correct? I took A, B, C, D like this. I don't remember. Yes or no? Otherwise, no problem. Don't by heart. I think usually I take A, B, C, D like this. I go in the counterclockwise. ಮೋಸ್ಟ್ ಫೋರ್ ಇರಬೇಕು, ಕರೆಕ್ಟಾಗಿದೆ ಅನಿಸುತ್ತೆ, ನನಗೆ ಗೊತ್ತಿಲ್ಲ. ಡೋಂಟ್ ಟೆಲ್ ಮಿ ಸಾರ್ ಅವತ್ತು ಕ್ಲಾಸಲ್ಲಿ ಎ ಬಿ ಇಲ್ಲಿ ಸಿ ಹಾಕ್ಕೊಂಡ್ರಿ ಅಂತ. ಅಯ್ಯೋ. ಓಕೆ, ನಾವು ಸ್ಟಾರ್ಟ್ 1 by 1. ಸಿ ಸ್ಟಾರ್ಟ್. ಫಸ್ಟ್ ಕನ್ಸಿಡರ್ ಓನ್ಲಿ ಪಿ. ಕನ್ಸಿಡರ್ ಓನ್ಲಿ ಪಿ. ದಟ್ ಈಸ್ axial load. Axial load. Remember, when you want gross pressure, instead of P, I will tell you increase by 10%. Okay, P. Then this is axial load. Pressure will be pressure, that is pressure on what? Or you can get pressure sufficient. Pressure will be uniform. Uniform. Uniform means what? That is constant everywhere. Constant everywhere. Everywhere. Given by, tell the answer. If P is the force, what is the pressure? Or if you consider only axial load, if P is the load, tell the pressure. Pressure equal to upward pressure. Pressure means upward pressure. Everywhere, what? Right here. This pressure everywhere will what? Will compress the soil. Compress the soil, or from soil it will be upward on footing. On footing. These all you are right. This load P will compress the soil, or from the footing, from the soil to footing, this pressure is upward. Given by formula. Given by formula. Pressure due to axial force, you already know it. 10%. ನಿಮ್ಮ ಕಮೆಂಟ್ಗಳು ತುಂಬ ಲೇಟಾಗಿ ಬರ್ತಾ ಇದೆ, ಯಾವುದೋ ಹಳೆಯ ಕಮೆಂಟ್ಗಳು. ಏನು ಫಾರ್ಮುಲಾ? ವಾಟ್ ಇಸ್ ದ ಫಾರ್ಮುಲಾ ಫಾರ್ ಪ್ರೆಷರ್ ಡ್ಯೂ ಟು ಆಕ್ಸಿಯಲ್ ಲೋಡ್? ಆಲ್ರೆಡಿ ಟೋಲ್ಡ್ 1000 times. P by A, given by P by A. Therefore, ನೋಡಿ, if I write the pressure variation here and do one thing now, what I will do is, if what? Soil is pressed down, or if soil is compressed, or when pressure from soil is upward. If the soil is compressed, whether it is pressure from soil is upward, we will take it as positive. So therefore, I will write here, due to P, it is plus P by A, 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 ಎಲ್ಲೆಲ್ಲೂ हर जगह P by A. But remember, technically wrong. Because of the soil settlement, soil subgrade reaction, pressure will vary. That we are not considering, but software will consider, because there you are giving soil subgrade reaction. We don't consider. We are going as per strength of materials, means unyielding soil. If uniform settlement is there, no problem. If non-uniform settlement is there, then there will be slight variation that in the class we are ignoring. But software, when you assign subgrade reaction to the footing slab, I will tell you later. It will ask you, what is the soil subgrade reaction? I will tell you in the ETABS class. Then you can see result from our class and result from software will slightly vary. Here pressure can come 120, it may come there 118 to 125 like that. Okay, leave it. Okay, over. P by A. This is due to P. Okay, now consider M1. Remember now, I am not taking strength of materials class here, but I have to take principle if it is a basic RCC class. Fortunately, for the basic RCC batch, I already explained this one. They know it. And for ETABS batch, I should tell principle. I cannot go to derivations. So, at general public, whatever I give, accept it. That's all. Whatever I give, accept it. Okay, over. So, see, M1. That means, one thing forgotten. Tell me, what is area here? Area means what? See, these all dimensions is planned. Tell me, what is area? Area, how much? What is that area equal to? What is that area equal to? Contact area. That is called plan area. How much area? ಗಂಟೆ ವೆಯ್ಟ್ ಮಾಡಬೇಕು ಒಂದು ಆನ್ಸರ್ ಬೇಕು ಅಂದರೆ ವಾಟ್ ಈಸ್ ದಟ್ ಏರಿಯಾ ಈಕ್ವಲ್ ಟು ನೋಡಿ ಅಗೈನ್ ಸೇಮ್ ಥಿಂಗ್ ಐ ಹ್ಯಾವ್ ಟು ಆಸ್ಕ್ ಎ ಕ್ವಶನ್ ವೆಯ್ಟ್ ಫಾರ್ ಹಾಫ್ ಆನ್ ಅವರ್ ಐ ಕ್ಯಾನ್ ರೈಟ್ ನೋ ಡೋಂಟ್ ಟೆಲ್ ದ ಹಂಬಲ್ ಕಮೆಂಟ್ The one who is taking class in YouTube, a person takes a class by the name KSN, he does not know everything. Everything he is asking us, when we tell, he writes the answer. Let him comment, people will be there. In Hindi, उसको कुछ नहीं पता. हमसे बोल के लिखता है ಕನ್ನಡದಲ್ಲಿ. ಏನು ಸಬ್ಜೆಕ್ಟೇ ಗೊತ್ತಿಲ್ಲ, ನಮ್ಮನ್ನ ಕೇಳ್ಬಿಟ್ಟು ಬರೀತಾರೆ, ಏನು ಪಾಠ ಮಾಡ್ತಾರ ನೋಡಿ. ಆಯಿತು, ಅಂದ್ಕೊಳ್ಳಿ, ಪರವಾಗಿಲ್ಲ. ಯು ಡೋಂಟ್ ಥಿಂಕ್ ದ್ಯಾಟ್ ವೇ. ಏರಿಯಾ ಈಕ್ವಲ್ ಟು ಇಲ್ಲ, ಪೀಪಲ್ ಆರ್ ದೇರ್. ಯು ರೈಟ್ ಐದರ್ L1 into L2 or you can write L2 into L1. This all in the column I told. See area S1 by S2 or S2 by S1. Completely your choice. No effect. Okay, start. Consider M1 this way. M1 means axis 1 1. ನೋಡಿ ಇಲ್ಲಿದೆ, axis 1 1. ಈಗ ಕೆಂಪಿಲ್ಲ, ಓಕೆ ಆಯ್ತು ಬಿಡಿ, ಕೆಂಪೇ ಬರಿತೀನಿ. ಐ ಯೂಸ್ ರೆಡ್ ಕಲರ್. ವೈ? ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್. Axis 1 1. Your moment is like this. It can be like this or it can be like this. Don't by heart. M1. You write here, it can be like this also. This is A, this is B, this is C, this is D. M1. Now, or see, this way. Tell me, will it press back side or front side? One side it will press, one side it will lift. Tell me, where pressing? Which side it will press the soil as per this sketch? Which side it will press the soil as per this sketch? Back side or front side? It will press the soil on back, rooting soil on the back side or front side? This M will press the soil on the back side or front side? ಅಯ್ಯೋ, ಇಷ್ಟು ಡೌಟಾ? ಈ lag is creating problem. Back side, therefore back side presses, here it will be what? Therefore on the back side the pressure is plus. Tell me, front side, this is axis, no, this axis. Front side, will it press the soil or tendency is to get lifted? Front side, tendency is to press will it press the soil or tendency is to get lifted? Tendency is to get lifted. Lifting is good or bad? Tell me, do you want lifting? Do you want lifting? Tell me, do you want foundation to get lifted? No, it is bad. Therefore minus here, ಇಲ್ಲಿ plus, minus. Now tell the answer. This pressure I want, this pressure I want. This is a bending theory pressure. This is M by Z. This also M by Z. But M by Z about the axis 1 1. So I will call this as what? M1 by Z1. This I will call also M1 by Z1. That side plus, this side minus. And remember, Z is section modulus. Section modulus equal to BD square by 6. That is structural. Tell the answer. For M1, tell structural B and structural D. Structural. Tell the answer. For moment M1, see here, what is the structural D? One side is L1, other side is L2. Which is the structural D for M1? Bega. This I should not tell, because if you still got doubt, then what you are doing in the column chapter? When the bending is this way, tell me, structural D is L1 or L2? L2. Sorry, if anybody not clear, imagine someone He saw these classes recently. Someone told me recently. Recently I came to know. Okay, then he may tell, sir, columns I have not considered. Go and consider. I told you, my class, go and study. So, structural D is L2. Why? By heart, crude method. If moment is this way, tell the crude method how your hand is moving. Along that is structural depth. I told endless number of times. And structural depth is L1. Therefore, this is the value of B and D. Now, lastly, consider M2. Due to M2. Due to M2. This is the axis 2. Moment is like this. M2. Tell me. Now, right side will get, it will compress the soil on the right side or left side. As per this sketch, it can be like this also. As per this sketch, will it press the soil on the right side or left side? Right side. So here, plus. Here, minus. How much answer? M2 by Z2. This also M2 by Z2. Here, Z2 equal to BD square by 6. Tell the answer. What is structural B and what is structural D? Tell the answer. For M2, nodi. For M2, structural D, which one? Some will buy out that way. Oh, gottagoitu. M1 ge L2 ge. They will tell gottai sir, M1 ge ulta. For M1, column C, they will tell M1 structural D is S2. For which one? For M1. For M2 ulta. Don't remember that way. Structural D is L1. Danger. Structural B is L2. Therefore, your Z will be what? Here, L1 into L2 square by 6. Here, L2 into L1 square by 6 is Z. Therefore, if I consider all these effects combinedly, tell the answer now. Now remember now, we consider P as the axial force. Now one note you are right. When you design the footing slab manually, first see what all I am telling when I am cleaning the board, you should write if you want to learn. I am going to dictate something now. During the cleaning, I will dictate. I will not tell a song here. You should write everything if you want to learn. Okay. I will start. When you design the footing slab, when the from column, when you get P, M1 and M2, how it comes we will see in the software class later. Then there are two pressures you have to consider. One of them is gross pressure, other is net pressure. When you want to check the safety of the soil, or when you want to check the stability, or when you want to ensure that pressure on soil does not exceed SBC of soil, then you have to consider gross pressure, where weight of footing also is considered. Okay. Then, but later, when we go for design of the footing slab, like cantilever action, bending and shear force at critical section, A plus B by 2, etc., then punching shear, this shear, that shear, wide beam shear, etc., there also we need pressure. But that pressure is not gross pressure. That pressure is, answer. That pressure is not gross pressure. That pressure is, what pressure? That pressure is not gross pressure. That pressure is net pressure. Now, when you consider gross pressure, consider 1.1 P. Assuming that weight of footing slab and other small things as 10% of the column load, when you find net pressure, same formula, don't take 1.1 P, simply take P. Now, there is a reason why gross pressure 1.1 clear. When you do net pressure, why only P? There is a reason. Do you want to know the reason? It has got beautiful reasoning. It is not a crude method. Don't try to ask in the colleges all. They will tell. If you ask that way, in the colleges, usually they tell, hey, you are acting too smart. I know how to take care of you. ಕನ್ನಡದಲ್ಲಿ ಏನು ತುಂಬ ಮಾತಾಡ್ತೀಯಾ, ನನಗೆ ಗೊತ್ತು ಏನು ಮಾಡಬೇಕು ಅಂತ. ಹಿಂದಿಲಿ ಏನು ಬಹುತ್ ಬಾತ್ ಕರ್ತೆ ದೇಖ್ತಾ ಹೋ ತುಜೆ ನೋಡಿ. ಡೋಂಟ್ ಟ್ರೈ ದೋಸ್ ಥಿಂಗ್ಸ್. Reason I will tell you later, confusion. But actually, it has got beautiful reason. Want to know why or no? Yes, no. Reason is simple. You think you get the answer. Illa. Sorry. In this class all, if I tell such reasons, it will become deep concept subject. No. You should learn it yourself. In the RCC class, I told it. In the RCC class, I will tell it. And also, there is one more subject called basic structural knowledge. There I am going later for combined bending and axial force. At that time, those who are coming for BSK class, I will tell at that time. Don't worry. I will tell at that time. This theory will be more clearly explained furthermore in the BSK class. After bending test, I am explaining. Other public, you believe me, you, by this time, you should think, this person somewhat knows, okay, done. Therefore, gross pressure at any corner, remember, we always want corner pressure. Why? Critical is always corner. Any corner, that is called PG, anywhere equal to formula is plus PLR, not a gross pressure. I write here, to be used for comparing with the SBC and also considering stability, plus P by A, plus 1.1 P by M2 by Z2. Where, I will write a sketch here to make fully clear. This is your M1. It can be like this also. Be careful. You write here, either that way or it can be like this also. Anything will do. M1. This is your M2. Or it can be like this also. P is here. This is L1. This is L2. This is 1-1. This is 2-2. 2-2. Now tell the answer. Where A is L1 into L2. First tell me Z1 or Z2. Those who want, make a note. General formula for Z is either L1 into L2 square by 6 or L2 into L1 square by 6. Make a note. Squaring is always for structural depth. Tell the answer. For M1, first answer. For M1, which is the structural depth? First, area is L1 into L2 or L2 into L1, no problem. For M1, structural depth L2. Therefore, it is L1 into L2 square divided by 6. Tell me, for M2, which is structural depth? Tell me, for M2, which is structural depth? L1. So, therefore, this is, therefore what? This is what? L2 into L1 square divided by 6. And remember, P by A is always positive. ನೋಡಿ ಬರಿತೀನಿ ಈಗ, P by A is always positive. ನೋಡಿ, plus, 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 plus. Now, I will tell you M1 by Z1. ಹೇಳಿ ನೋಡ್ಕೊಳ್ಳಿ ಈಗ, I will tell you M1 by Z1. ಹೇಳಿ, ಆನ್ಸರ್ ಫಾಸ್ಟ್. I will tell you M1 by Z1. This is your axis 1, 1. Tell the answer. If the M1 is like this, tell me, plus on the back side or front side. If your M1 is like this, plus means pressing the soil. Plus means pressing the soil down. Plus on the front side or back side. If M1 is like this, plus means pressing the soil down. Minus means getting lifted. Fast, fast. If M1 is like this, which side is pressing the soil down? Front or back side? First part. ಅಯ್ಯೋ, ಬ್ಯಾಕ್ ಸೈಡಾ? ಇದೆಲ್ಲ ಎಲ್ಲಿ ಸಿಗುತ್ತೆ ನಿಮಗೆ? ಸಾರಿ, ಬ್ಯಾಕ್ ಸೈಡ್. Therefore, where it presses, what? ಈ ಕಡೆ ನೋಡಿ. Whereas ನೋಡಿ, ಉದ್ದಕ್ಕೆ ಬರೆಯೋಣ ಈ ಥರ M1 ಆದರೆ. ಆರ್ if M1 is like this, tell me now, if the M1 is like this, pressing the soil is front side or back side? If M1 is like this, pressing the soil is front side or back side? Front side. Therefore, this is plus understood. I am discussing this term. Okay. And ಇದು P by A, ಇದು M1 by Z1. Consider M2 by Z2. Two cases. If it is this way M2, tell the answer. Pressing the soil is on the right side or left side? Pressing of the soil is on right side or left side? If M2 is like this, the pressing will be on right or left side? If M2 is like this, no answer. I am asking question. If M2 is like this, right side will press, left side will get lifted. Whereas in case or if M2 is like this, tell me now, pressing the soil is on the left side or right side? Pressing the soil is on left side or right side? Left side. So positive, positive, negative, negative. Clear? Clear or not? Or there is a crude method. Want to know it? There is a crude method. Want to know it or not? Tell the answer. Yes. No. Do you want a crude method? Do you want a crude method? ಬೇಡ ಅಂದರೆ ಬೇಡ. ಬೇಡವಾ? ಓಕೆ. ನೋ, ವೆರಿ ಗುಡ್. ಮೇ ಬಿ ಯು ಡೋಂಟ್ ವಾಂಟ್, ಬಟ್ ನೋಡಿ ಕೆಲವರು ಬೇಕು ಅಂತಾರೆ. ಹೇಳಲ್ಲ ಏನು ಅಂತ ಯಾರಿಗೆ ಬಿಡಿಸಿ. M1 ದಿಸ್ ವೇ ನೋಡಿ, ಈ ಥರ ಇದ್ದರೆ ವಿಚ್ ಸೈಡ್ ಇಸ್ ದ ಆರೋ, ದ್ಯಾಟ್ ಸೈಡ್ ಈಸ್ ಪ್ಲಸ್. ವಿಚ್ ಸೈಡ್ ಈಸ್ ದ ಟೈಲ್, ದ್ಯಾಟ್ ಸೈಡ್ ಮೈನಸ್. ನೋಡಿ ಈಗ ಆರೋ ಆನ್ ಬ್ಯಾಕ್ ಸೈಡ್ ನೋಡಿ, ಆರೋ ದಿಸ್ ಸೈಡ್ ಪ್ಲಸ್, ಟೈಲ್ ಹಿಯರ್. ದಿಸ್ ಒನ್ ಆರೋ ಹಿಯರ್ ಪ್ಲಸ್ ಪ್ಲಸ್. ಇಲ್ಲಿ ನೋಡಿ Arrow is on right side, plus. Other side, minus. Arrow is this way, minus, minus. Now clear? You can make a note. Even crude method also is there. Clear or not? Okay. Now, this is for gross pressure. Make a note. Using gross pressure, first, first, apply the check. Check number 1. Maximum gross pressure should not exceed what value? Tell me. Maximum gross pressure should not exceed what? Bega. Maximum gross pressure should not exceed. Ittottu beka. Maximum gross pressure should not exceed. Ayyo. How much time to tell the answer? For the soil where you get maximum pressing, gross pressure should not exceed. Kaita anedi waiting for a long time. This way, it is better I only tell and close the class. If you take this much time to answer the question, this much lag is not there. This is not lag. I can hear my own voice now. Not really.
I can hear my own voice now.
I am hearing now. ಇಲ್ಲ ನಾನು ಹಂಗೆ ಕ್ಲಾಸ್ ಕ್ಲೋಸ್ ಮಾಡ್ತೀನಿ ಅಷ್ಟೇ. ಸಡನ್ಲಿ ಐ ಕ್ಲೋಸ್ ದ ಕ್ಲಾಸ್ ಎಟ್ ಗೋ ಗೆಟ್ಟಿಂಗ್ ಅನಾಯ್ಡ್. ಈಗ ಬಂತು ಅರ್ಧ ಗಂಟೆ ಆದಮೇಲೆ ಏನು? ಶುಡ್ ನಾಟ್ ಎಕ್ಸೀಡ್ SBC of soil. And check number 2. There should be no lifting anywhere. No lifting anywhere. Any corner, anywhere. And tell me, see, load will compress, moment will try to lift. We want load to be predominant or moment to be predominant. Tell me, we want load to be predominant or moment to be predominant. For stability, think common sense. For stability, we want load to be predominant or moment to be predominant. Which one? Load to be predominant or moment to be predominant? ಅದಕ್ಕೂ ಆನ್ಸರ್ ಇಲ್ಲ. ಫಾರ್ ಸ್ಟೆಬಿಲಿಟಿ, ಫ್ರಮ್ ಸ್ಟೆಬಿಲಿಟಿ ಪಾಯಿಂಟ್ ಆಫ್ ವ್ಯೂ, ಯು ವಾಂಟ್ ವಿಚ್ ಒನ್ ಟು ಬಿ ಪ್ರಿಡಾಮಿನೆಂಟ್, ಲೋಡ್ ಆರ್ ಮೊಮೆಂಟ್, ಪಿ ಆರ್ ಎಮ್? ವಿಚ್ ಒನ್ ಯು ವಾಂಟ್ ಮೋರ್ ಪ್ರಿಡಾಮಿನೆಂಟ್ ಫಾರ್ ಸ್ಟೆಬಿಲಿಟಿ? ನೋಡಿ, ಯು ಆರ್ ಟೇಕಿಂಗ್ ಬಿಯಾಂಡ್ ದ ಲಿಮಿಟ್ ಟೈಮ್ ಜಸ್ಟ್ ಟು ರೈಟ್ ಐದರ್ ಪಿ ಆರ್ ಎಮ್. ಇಲ್ಲ, ಏನು ಮಾಡೋಕ್ಕಾಗಲ್ಲ. ಇಫ್ ದಿಸ್ ಕಂಟಿನ್ಯೂಸ್, ನೆಕ್ಸ್ಟ್ ಟೈಮ್ ಅಯ್ಯೋ, ಯು ವಾಂಟ್ ಮೊಮೆಂಟ್ ಟು ಬಿ ಪ್ರಿಡಾಮಿನೆಂಟ್. ವೆರಿ ಗುಡ್ ಆನ್ಸರ್. ವಾಟ್ ಈಸ್ ದಿಸ್? ಯು ವಾಂಟ್ ಮೊಮೆಂಟ್ ಟು ಬಿ ಪ್ರಿಡಾಮಿನೆಂಟ್. ಏನು ಬಿಲ್ಡಿಂಗ್ ಟಾಪಲ್ ಆಗಬೇಕು ನಿಮಗೆ? ಡೂ ಯು ವಾಂಟ್ ಫೂಟಿಂಗ್ ಸ್ಲ್ಯಾಬ್ ಟು ಬಿ ಟಾಪಲ್ಡ್? ಅಯ್ಯೋ, ಹೌ ಯು ಥಾಟ್ ದಟ್ ವೇ? ಮೊಮೆಂಟ್ ಟು ಬಿ ಪ್ರಿಡಾಮಿನೆಂಟ್. Moment predominant means toppling chance. Stability comes because of the load. How your idea came, moment? How that idea came? First of all, I don't know how that idea came. Which one you want predominant? Which one you want more pressure? Moment or load? Someone told, I am going to close the class now. All others are silent. Nobody is answering. I am going to close the class, guaranteed. I am going to close the class. If this way you give response, I will close the class. After half an hour, someone told load predominant. Ayyo. See, load will give stability. Moment will give instability. See now. Moment will give instability. Load gives stability. Common sense. So, therefore, due to load, always plus. Due to moment, one side plus, one side minus. For no lifting anywhere, tell the answer. Nowhere gross pressure, nowhere gross pressure should be what? Tell me. Nowhere gross pressure should not be what? Gross pressure should not be. We want see, up to some limit, no problem. If it goes beyond the limit, lifting will come. Lifting should not come. So, maximum gross pressure should not exceed SPC, and nowhere gross pressure should be what? Nowhere. Net pressure. ಎದುರು ಬರ್ತಾ ಇದೆ ಆನ್ಸರ್. Nowhere gross pressure should be. It is so simple. I am surely going to close the class now. Still 15 minutes there. But this is beyond the limit. Nowhere gross pressure should be. But if I don't tell now, difficulty for me next time. Nowhere gross pressure should be. Right. Don't know what is the problem. Don't know now. Ayyo. Nowhere gross pressure should be negative. Negative. Now clear? If the gross pressure comes negative, that is lifting is predominant. We want everywhere positive. See, if I stand here, pressure is okay. If I slightly turn here, this side more pressure, that side still pressure is there, no problem. If I turn, good. If I turn beyond the limit, that side will get lifted, then stability gone. Therefore, remember, the condition is check number 1, maximum pressure should not exceed SBC, and check number 2, minimum pressure should not be negative. That is, everywhere we want positive pressure. Little tilting, okay. Why? Because of the weight. The tilting effect is lesser. My body weight is more. Okay. Nodiga. Hoಯ್ತು. Gone. Now clear? ಇದೆಲ್ಲ ಗೊತ್ತಾಗಬೇಕಲ್ಲ. Now clear? Maximum gross pressure should not exceed SPC. Minimum gross pressure should not be negative. Okay. What to do? Over. So this is the check. I will do one thing now. I will give an example for you. You try the pressure calculation. Let me see how many are getting pressures. Okay. See. There is a footing here. You try homework. Random question. This is A, this is B, this is C, this is D. Okay, now see. This dimension is 3 meter. This dimension is, say, 4 meter. And there is an axial load of 1200 kilonewton. Then further, there is a moment M1 of and M2 of. Moment M1 of ಒಂದು 90 kilonewton meter. M2 of 150 kilonewton meter. And you find gross pressure at A, B, C and D for following cases. Problem 1. M1 is like this. M2 is like this. Problem number 2. Same question once again. M1 is like this only, but M2 is like this. Question 3. M1 is like this. M1 is like this. M2 is like this. Question 4. M1 is like this. M1. M2 is like this. Values are same. Can you try now? And remember, I told find gross pressure. You make 4 answers. Pressure at A, pressure at B, pressure at C, pressure at D. For problem 1, problem 2, problem 3, problem 4. It will keep on changing. Then I will explain the meaning of maximum pressure and minimum pressure. Then we will enter what? Design of column footing for when the column is transferring load and M1, M2 both. Okay. Now, I will not go there because first of all, I was about to go and stop the class earlier, little earlier. I was about to go, getting frustrated for no reply. Then suddenly, someone told, Yaru, Shruti BS, she told load. You should have told earlier. I asked 10 times. I don't have to ask that much number of times. Okay. Now, will you try this question? Will you try the question here? 4, 3. Okay. Everything data is given. Yes. Will you try this question? 4, I will briefly solve here. But at least before the class, will you try this one? 4 times you put the answer here. 4 corners. Yes. Try that one. Try and get the answer. But I will tell briefly next time. Okay. Now, still 10 minutes time is there, but new I can't start, and because of no cooperation, I have lost the interest now to explain. At R I would have done at least 1 question here. Remaining I tell you try. No. Everything you try. Good for health. But don't worry. Even if I get upset, when I come to next class, I will be serious only. I will not skip anything. Don't worry that way. Okay, study well, thoroughly understand this one, go through today's class repeatedly and understand everything. Remember, learning is once in a lifetime, you should know it. Okay.